Okay, guys, is the audio any better just now? I've changed them. I'm trying to change the microphone settings to get the audio good for you guys. This is the first stream back up and running, so the audio is good now, is it? Oh man, teething issues. I haven't done a live stream in many months, and teething issues. I need to go and watch the stream back in a minute and see what the hell you guys are talking about, but it sounds pretty interesting. It was working in testing earlier today. I've reset up the stream station and it was working earlier, and now obviously when I start the stream it doesn't work. So I will start again. Good evening to you all, wherever you are in the world. It's evening here in the UK. It's a sweltering 28 degrees Celsius at 9:15 in the evening. Thursday is going to be a 37 degrees Celsius. That's the hottest that I have ever remembered experiencing in the UK. Freaking roasting. As a result, my PC here, which I'm using for live streaming, which is an old LGA 775 setup, which is overclocked to a freaking balls, is probably kicking out its last legs, and it's overclocked like a boss, and it blue screens occasionally. So if the stream disappears, don't worry, I'll be back in a minute once I've turned my CPU clock down a little bit. I think I found a stable clock, but we'll see. Mic is clipping. Alright, I'll turn the mic gain down a little bit as well. Okay, mic clipping. Mic should not be clipping anymore. So thank you guys for helping me sort out the audio issues. Okay, that should be a little bit better. It's not clipping anymore, is it? Okay, okay. I think we're going to roll with this. As long as you guys can hear what I'm saying. As long as you guys can see what I'm doing. So I have a few new camera angles for you guys this evening. So this is a new stream setup using the same cameras. However, so obviously I have this side camera, which looks pretty cool because it looks like I'm looking at the live chat. I'm looking at what you guys are saying, and I'll have this new camera, and this camera is attached to one of my lights, and the light is on a kind of mount which can move, so I can move this camera around and let go, and I can get right up close with things on the driver board, which is pretty darn cool. That's a very, very useful camera angle to have. I have the large camera, which is way up here, that you can see me doing some soldering on. I also have, this is a new one, and it deactivates when I'm not using it because I don't use it that often, but this one's pretty darn cool. This is, come on. Oh, I haven't got it plugged in because I have the mouse plugged in. Hang on a minute. I've run out of USB sockets, so I'm having to kind of switch USB sockets here. But now I've got no mouse, which I shouldn't need anymore. But this one is the camera which is attached to my soldering iron. So hopefully it'll activate. There we go. So you also now have a soldering iron cam. That's pretty cool. So you can see exactly where I'm soldering, and you can also see that I definitely need to clean my soldering iron tip. That pretty cool? So that's another new camera for you guys this evening. Alright, still clipping. Alright, let me turn it down a little bit again. I can't tell. I'll just have to talk quieter. I've lost my mouse now because I plugged that camera in, so I've lost the mouse. Right. Anyway, without further ado, I think we should get on with the amplifier repair. As long as you guys are happy with the stream quality, as long as the picture looks good, and as long as the audio, as long as you can hear what I'm saying. I don't have my RTA microphone hooked up like I usually do, but just let me know, is the audio acceptable and can you hear what I'm saying? That's all that's important, is that you can hear what I'm saying, and it's not crackling and clipping to hell, as long as it's alright. Cool cams, sounds crappy, sounds crappy. And of course we also have the scope screen, and the scope screen looks pretty nice. I've got a really good angle on this, it's nice and straight, and the focus is bang on point, so the scope screen is pretty awesome. You can also see the VRMS that's currently on the wave, and you can also see the frequency when a wave appears. Maybe I can get a wave appearing. Here we go. So I'm just touching the end of the probe here. Yeah, so that's a pretty cool scope cam. Hopefully you guys will enjoy that one. Mic is more like clipping. Alright, I'm going to try and turn the mic down a little bit again. So by turning the mic down earlier, did that help out a little bit? I'll turn the mic down a touch more, and hopefully that should sort it. I'm just going to go ahead and go into my sound settings. One, two, okay, here we go. Mic settings, levels. Here we go, let's crank that down to about 29. Okay, that's a much lower mic setting, so that should have fixed it. Let me know if that's fixed the mic, guys. I'm also going to go ahead and turn the audio quality, I was going to turn the audio quality up a bit. It's on 128 kbps, just to save a bit of CPU. Is that better? Awesome. Okay, I think we're ready to do some amp repair. So, as you guys can see down in the corner of the screen here, the amplifier that we're going to be working on today is a solid audio F2500D. If you have been in the car audio game for a while, or any sort of number of years, you will have probably seen this amplifier before. This is an old school Class D 2500 watt board. The difference is it doesn't make 2500 watts at 1 ohm. I bench tested these a number of times, and these amplifiers only make 2500 watts or more at 0.5. At 1 ohm they make about 1850, 1900 watts. They are on old school design, and they are using P channel and N channel MOSFETs in the output section. So they use 640N, which is the N-channel MOSFET, and they use 9640, which is the P-channel MOSFET. The driver board here is in a different form factor to what you might be used to seeing, but it is the same as a driver board that you might see in the likes of Hyphonics. SPL Dynamics EXT2000D is another one that uses this style of driver board, and this style of driver board where you are seeing transistors labeled up as AG and DK. These amplifiers will use N-channel and P-channel MOSFETs, and they are an older design. You might also notice here that Q22, the picture seems to be mirrored. I might have to fix that, but yeah, Q22 here has some burn marks on there. So most likely we have a dead drive circuit on this one. Now, I also noticed, I just want to bring your attention to this. So this amplifier has come in, and we have a dead output section, and we have a dead power supply section. So this amplifier is going to be a full rebuild. We can see over here in the power supply section plenty of soot and blown MOSFETs, and the output section, although dead, doesn't show any signs of failure. And this is one thing that gets me when people open up the back of their amplifier and they say, oh, I can't see anything wrong with it, it seems to be fine, why doesn't it work? I can't see anything wrong. Well, all of these MOSFETs along here are dead, they're shorted, but you don't see any visual signs of damage. So the reason that the power supply over here has failed is because these MOSFETs are shorted, so the power supply was trying to drive a dead short on the output section, therefore couldn't, therefore exploded. So we've got a full rebuild on our hands, which I thought would be a pretty fun live stream to do. Now, the reason that this amplifier failed, sometimes it's difficult to tell why an amplifier has failed. Even myself as looking at these things, the output section can just be dead, and it doesn't seem to be any real obvious external causes of fault, like someone shorted these speaker wires, it's quite obvious to see, or like vibration damage is quite often a massive cause of amplifier failure, or some small strand of wire that's fallen inside the amplifier. That's also quite easy to see. In this case, I think I can see the failure here. If we take a look at the driver board, this is on headers, and if we look closely and let the camera focus, he says let the camera focus, come on, focus for me baby, there you go. You can see that the driver board has actually lifted itself slightly out of the headers here. So this driver board comes from factory in headers like this, and it's glued down at various points over here. However, if this amplifier is mounted to an enclosure or is subject to sufficient vibration, then the driver board can start to walk itself out. and it's not glued in over this side, and so it will start to walk itself out over this side. And these pins over here are responsible for driving. This is the gate drive path for this bank of MOSFETs. So even if this pin made a disconnection from the header, even for a fraction of a second, then it will not drive this bank of MOSFETs properly, and they will most likely blow. So that's probably what's happened here. And if you can see, if I push back down on this driver board, it goes in quite a long way, and it actually springs back up because of the glue on the other side. So I'll be cutting this glue away, and I'll be securing this in a slightly better fashion when we come around to the repair. So that's what I think the cause of failure is on this amplifier here. Start taking this baby apart. So I'm going to check out the live chat right now, but because I have no mouse, I don't have a mouse hooked up to my PC at the moment, because I have used up all my USB sockets with cameras. I can only see what's on the current screen, so I can't scroll back up. So I'm glad the audio is fixed. It looks like an EA1800D. It's a Car Power Raptor. I haven't actually seen any of the Car Power amplifiers. Back in the day, I used to kind of long after the Car Power woofers, the ones with the spider assembly on the back of the motor. It looked pretty cool. I thought it was a really unique design, and they had pretty high excursion for their time. But I never saw any of their amplifier range. Alright then, so to begin the repair of this, the first thing we want to do is remove all the dead parts. Now, because this amplifier has one whole side of the output section failed, it would make more sense to just replace the whole lot. So even though this side of output MOSFETs is actually perfectly intact and is not damaged in any way, we're going to be replacing these anyway so that they're matched over with the other side. This amplifier is essentially I think this is 4 separate amplifiers in parallel with each other. With a Class D amplifier, you can look at the number of output inductors, and that tells you how many smaller amplifiers are inside the board to make up a mono amplifier. So these 4 amplifiers are all parallel together to drive a 1 ohm load. So although we have 2 of these amplifiers that survived and remain okay, it makes more sense to just replace all for the same batches. Stephen says, thanks for recommending Perry's amplifier repair guide. Yeah, that's the thing that actually got me started and gave me enough basic knowledge to begin repairing car audio amplifiers. I can't recommend that guide enough. It's a fantastic source of information. A lot of the stuff in there is a little outdated now. It goes over some more older circuits. It doesn't cover a lot of the newer Class D stuff from Brazil, but it is an invaluable tool and asset to have to learn about car audio repair, and it talks about things that surpass different types of amplifiers like vibration damage, etc., and how to look for that. Yeah, it's a fantastic tool to have, and I highly recommend that. Oh yeah, so I was going to talk about the rail caps as well. So let's take a look at these rail caps. Now you may notice that these rail caps, they don't look quite right, do they? There's something a little bit wrong with these. The insulation on the side here doesn't make its way all the way to the top of the capacitor, and you might think that the capacitor's dead. However, that's not the case. If you look at the capacitors on this side, they appear fine, and then gradually, as you get towards the middle, the heat shrink along the outside of the capacitor kind of shrinks down, and it's a bit strange, but the capacitor doesn't look bulged itself. So the reason that this happens is due to heat. The insulation, the wrapper on these capacitors is like a heat shrink. So with heat, it'll shrink in size. And obviously in the factory, when these capacitors are produced, they are heated to a certain level. But if these capacitors are subjected to continuous heat in operation, then this will gradually, over time and over many years, shrink even further. And the reason that these have shrunken down is most likely because they are near to these pull-down resistors, which I'm not sure if the camera can make out. There is pull-down resistors just in here, which run very, very hot indeed, and they are also very, very close to the output inductors, which also run very, very hot in these amplifiers once they are up and running and you're drawing power from them. It's totally normal, it's not a fault. The output inductors are turning the high frequency noise into heat. Essentially, that's how they filter it out. So you'll see that anything that's near to the inductors has the capacitors with a much shorter insulation, and then the ones that are further away from the inductors over here haven't been subjected to that continuous heat over the number of years this amplifier has been in operation, and therefore has not shrunk. But the capacitors themselves are fine, nothing wrong with them at all. So let's get to removing these old dead MOSFETs, and this is the first time that I'm going to be attempting to use the soldering iron cam. So I don't know how this is going to go, because this is a pretty bulgy thing on the end of my soldering iron. It's like duct taped camera to the freaking soldering iron. So I've got slightly limited hold. I mean, I can still hold it pretty well, but it's a bit of a pain in the butt. But it is a pretty awesome camera angle that I wanted you guys to have. So without further ado, let's get this stuff turned on and removed. And I've got it on a fixed focus as well, so it only focuses where the end of the soldering iron tip is here. Gaffer cam, yeah man, absolutely. So there's a few methods which you can use to remove these MOSFETs. The first method is to cut the MOSFETs off entirely and then just pull the remaining pins out of the board. The second way is to cook up all 3 pins at the same time. I'm just going to bring this camera over here. Is to cook up all 3 pins at the same time and then pull the MOSFET out with like some pair of pliers. And the third method is to cook up these pins individually, use a solder sucker to suck the solder from the holes of each of these, and then pull the MOSFET out. I'm going to go for option number 2 to start with. That's usually the quickest I've found. I have actually timed this. I'm a bit sad. I've timed the different methods of removing these old MOSFETs to see which way is the quickest, and usually in most boards this method of just cooking up, there we go, it's out already, cooking up all 3 legs at once and removing them from the board is the quickest way to do it. But it will depend on the board in question. Some boards have too high thermal mass to do this effectively, and it's better just to cut the legs off and remove each leg individually. But with this board we can do a pretty decent job like so. I might actually have to put this camera on a foot pedal. So if you guys are new to the stream, you might not know that I use a foot pedal underneath the desk to switch camera angles. I only have 3 pedals, so I can only switch between 3 camera angles. The remainder of camera angles are on a hotkey on my keyboard. But obviously with both hands full like this, I can't switch cameras back to this angle if I decide to change it. I generally try and keep the 3 most used camera angles on the pedals at all times. And that being the side cam, where I can look at you guys in the face, in the eyes, and then the next camera is the one that's now on a moving arm. That's a pretty useful camera to have. And then the last pedal is on the fixed camera, which is above the desk, which you've seen. Those are the 3 angles that I would say I use the most. So they're on the foot pedal. But this one could quickly be upgraded to foot pedal worthy if it goes alright. How are you guys finding this angle? Is it a bit disorientating, or is it okay? Is it a bit glitchy? Is it a bit slow? Can my computer handle this number of USB inputs at once? I mean, I think that looks pretty cool. I'm trying to look at the screen at the same time as doing this, and you can see the sucking the holes pretty nicely there. I think this is a pretty dope angle. Maybe I can just move the camera around a little bit. Hang on, let's go. Let's get that down a bit. There we go. So you can see here, this leg has actually stayed in the board because this MOSFET snapped a leg. So I'm just going to go ahead and remove that one. There we go. And guys, just let me know as well whether this camera angle is like a little slow, whether it looks like it's a low frames per second, or whether it's like stopping and starting all the time. Because on my screen right now on OBS, it looks a little bit glitchy. It looks like it's sort of struggling to keep up with the movement a little bit. But it might actually be okay on the stream. It's difficult to tell. So sucking these holes, this is probably the most time-consuming part of the repair, is just removing all of the dead parts. Removing dead parts is, yeah, by far the longest part of a repair. Unless you have something that is taking a long time to diagnose where the issue is. If you have an amplifier that has a problem that just doesn't seem to make sense, and you're going through and spending hours like testing parts and stuff, then that's obviously time consuming. But in general, if you've got a generic amplifier that you know how to fix, the most time consuming part is removal of the old components here and sucking them holes. Well, let's flip the board over. Yeah. So yeah, you guys are saying that it's a little bit jumpy, but more than acceptable. I'll go with that for today. I will try to actually, one of the things which I want to do, so in the workshop here, the live stream PC will most likely always be this old 775 build, which is a really old computer. But in order to improve the stream quality and the speed of these cameras for you guys, I found that I can invest in a better graphics card, which I can use GPU accelerated NVENC. I don't know if that's like a acronym. I don't know if you're supposed to say it all as a word, but the acronym NVENC is something that OBS software can use, which speeds up and takes a load off the CPU, which is my bottleneck. The CPU is a heavy bottleneck on this machine, so I might be able to invest in a better graphics card which will enable me to use NVENC processing for rendering on OBS, and that should improve the stream quality for you guys a little bit. Every time I go back to this camera here, the camera will go black to start with, which is okay. Mic is still clipping. Is the mic really still clipping? Jesus, that's pretty bad. On my screen here on OBS, the audio level is way in the green. It's nowhere near the orange or red. So if the mic is clipping, then it must just be in the actual internals of the camera and the mic itself, rather than clipping in the mixer. I'll try and talk a bit more quietly so it doesn't clip. There we go, so that's all the old power supply MOSFETs removed. I'm just going to try and straighten up the camera a little bit on here. So I'm just going to suck the holes from this side of FETs. Then we can start with our power supply repair. Yeah, in terms of microphones, okay, so if you guys have been watching my streams from before, the audio quality used to be much better, and that was because before I was using a Behringer RTA microphone, the ECM 8000 I think it is, and that is the preferred microphone, which sounds great, but I didn't get round to hooking that one up this evening because I'm currently using that microphone for some voiceovers on a new video that I'm working on for you guys. So the RTA microphones are currently upstairs on the video editing machine because I'm doing some voiceovers. So I thought the stream would be okay to use the built-in mics on these webcams, but it seems that perhaps that's not such a good idea. But I will take note, and the next live stream for you guys will be done with the RTA microphones back in place, and the audio should be much better. But just going back to that video that I said that I'm doing for you guys. So at the moment I'm currently in the process of doing a video which is a extremely exciting video. I'm very, very excited to release this one for you guys. The video that I'm working on at the moment is a complete teardown and repair of a JBL GTI 6000. So it's the A6000 GTI, the JBL crown amplifier. I had one of those guys come in for repair, and I'm doing a complete video, like all edited with voiceovers and nice camera angles and everything, to show you how the amplifier is assembled, what components are used, and how to repair it. It's gonna be freaking sweet. So that's why the RTA microphone is on voiceover duties for that. But yeah, if you're interested in checking that out, then hit the subscribe and the bell icon, bell notification, so as soon as that video comes out you can check that out, because it's going to be awesome. I know that with the JBL Crown A6000 GTI, I know that Big D Wiz, Derek, has done a video on it in the past, and the Amp Lab has also done a video on that amplifier. The Amp Lab was, I assume, intending to do a 3-part video, and they only ever uploaded part 1. If you go to the Amp Lab's YouTube channel, you can see that the latest video from them was about a year ago, and it was the teardown of the A6000 GTI, and it was labelled up as part 1. And part 2 and 3, I guess, never happened. So I intend to take over from that and give you guys a proper video with a proper teardown and a repair of what I believe to be one of the best designed car audio amplifiers ever to grace the surface of this planet. There you go. These output MOSFETs are actually just falling out the board. I don't know if this camera will make it out, but literally I'm just going to go across the pins and then they're gone. It's fallen out. They just fall straight out the board. I love it when that happens. I've got to remove this little rubber thing here, and then this is the last MOSFET on this side in the output section. I'm just going to add some new solder, go left and right a few times, and boop, it's fallen out. And then I have a nice little pile of old MOSFETs down there. I'm just going to do the same on the other side over here. If you're having to really tug on MOSFETs to remove them from the board, then you're doing something wrong. Either you need to add more fresh solder, or your iron's not hot enough, or the MOSFET is at the wrong angle. Yeah, these are literally just falling straight out the board. You can see it there on the camera. So pretty nice. There's a couple here that will just need a little bit of a tug from the other side. That one's gone. That one's gone. And last but not least, ta-da! Adding solder to remove. Yep, a strange concept, but it works. Most of the reason that you add the solder to remove is the new solder is obviously much newer, and it flows easier, but also the solder contains flux, which will help the old solder loosen up. Last couple of FETs on the output section, and then we're good to go. That duct tape camera is in the way. Word. Okay, let's put this one back. So that's the soldering iron out of the way for a bit. Okay, so let's turn this over, see what we need to do. So on this amplifier, the power supply section is over here. As you can see, apart from the MOSFETs being visibly damaged, we also have some visible damage to some resistors over here. So let's pull this over here and get a little closer up view of this. The camera will focus in this close, you just have to give it a second. There we go. So these resistors, which are next to the power supply MOSFETs, these look pretty burnt as well, and these are called gate resistors. So what these do is these are in series with pin number 1 of the MOSFET, which is what's called the gate, and this is the signal which tells the MOSFET to turn on or off. So on the middle pin here we have 12 volts, which is passed through the transformer, and on the third pin we have ground. And when the MOSFET is told to turn on, it'll drag some current through the transformer before switching very quickly off again, and then the current is dragged the other way back through the transformer from the other bank of MOSFETs. So the reason that these resistors have burned is because when these MOSFETs short, they short out on all 3 pins. So when you are meant to only have 12 volts on pin number 2, when the MOSFET shorts, you also get 12 volts on pin number 1. And the 12 volts then goes back through the resistor, down this trace, and back round to the drive circuit, which is over here. And then these are most likely PNP transistors, which are also pretty FUCKED. As you can see, these are PNP transistors, and these will be responsible for turning the drive off. And because they're PNPs, when you feed them with 12 volts, these are also connected to ground, and they get very hot, and when they blow, they also short to ground. So then the reason that these blow and get very hot, and the reason that these gate resistors blow and get really hot, is because you then have 12 volts, which is meant to be on here. Come on, focus for me, baby. 12 volts, which is meant to be on here, then ends up on here, goes through this resistor, burning this out as current flows through this PNP transistor and to ground on the middle pin, which is why it burns, because it's a direct short circuit across 12 volts. So let's remove these as well then. So those oh damn, those transistors are over here on the board. So those PNP drive transistors, which we also need to replace, are these ones here. We have 1, 2, 3 legs. I'm just going to see if that looks any clearer if I turn the light off. So this camera is attached to a light. Yeah, it does, look. If I turn the light off that's attached to that camera, it actually looks a little bit better. I'm going to do that for the time being. So yeah, we need to remove those as well. So I'm going to go ahead and grab my soldering iron cam once more and get those out of here. So in response to Daniel's comment, that is one burnt board. I would have took that as trash. So the board itself isn't actually burnt. It just looks bad because the board is coated in black soot from the burnt MOSFET. So the majority of the circuit here is actually fine. It's quite a simple repair, just MOSFETs and drivers. The amplifier is long from being trash worthy. Just need to know what to replace to get it back up and running. I'm just lifting these transistor legs up in the air a little bit, and that's actually almost fallen out already. So those pins are now disappeared, which is pretty cool. Just lifting these pins up so they are straight in the holes. And yeah, that's also almost fallen out. So I have no more pins on the bottom here anymore. Let's flip the board over. The camera on this keeps moving. I think it's now slightly out of focus. I'm probably going to have to play with this a little bit to keep it in focus. So I think it needs to come back a touch. There we go, that's that one removed. And that's that one removed. Let's get rid of these old legs as well. And there we go. Suck some old solder. As you can see, there's a fair bit of old crappy solder floating around in there. Oh damn it. This freaking solder sucker has got clogged up again. Take a little look inside here, what we got going on inside this bad boy. Ooh, stink! There's a great big clump in here. Let's just remove that. Look at the size of that. Big stanky soldery boy up in my sucker. I'm just getting rid of the worst of the solder from the top of the board here, but it looks like I can actually suck most of the solder from these holes from the top of the board, which is pretty handy. Yeah, there we go. Pretty nice. On the camera, this board actually looks a lot worse than it is because we've got such high intensity light and the light is also clipping slightly. Yeah, it makes everything look kind of dirty, but in real life it actually looks okay. It doesn't look so bad. Okay, so now the drivers are out and we have all of the power supply FETs out of the board. The next thing that I want to do is just confirm that the TL494 chip, which is this bad boy right here, is fully functional. So on these amplifiers you'll have a chip which is called a 494 chip, and this is responsible for generating the square wave pulses that run the power supply. This generates pulses on pins 9 and 10 over here that then get sent through these PNP pull down buffer transistors. In a sense, they're just pulling the wave down quicker before going over to the gates of MOSFETs over here. So I just want to make sure that that chip is still working okay, and we can do that by applying some power to the amplifier and viewing the wave on the scope screen over here. So let's turn the soldering iron off. I'm just going to go ahead and apply some power to the board. Volt input over here. And finally the remote. There we go. So if you check out the scope screen right now, you can see that I'm wicked. Yeah, I think I can bring this camera over and I can show you exactly what I'm probing with this camera. That's pretty awesome. So if I probe pin number 2 of the power supply MOSFET location, you can see there that there is at the moment 10.2 volts, which is about what I've got going on in the power supply over here. If I probe the gate, I should have nothing. That's correct. And if I probe the source, I should also have nothing. That's also correct. So in order to see whether the TL494 chip is working, I'm going to go over to the chip here. And I'm going to probe those pins which I spoke about earlier, pin 9 and 10, and I should see a square wave appear on the scope screen. Just going to go ahead and turn the scope to the correct settings. I need to reject low frequency, keep noise rejection off, and 2 microseconds and 5 volts divide. Oops, wrong pedal. Yeah, pretty nice. So that is the square wave on pin number 9, and that is the square wave on pin number 10. So the TL494 chip is working and fully functional. That's all good. And then we should then see that same square wave on the pad locations for these PNP drive transistors. And it should be on pin number 1 and pin number... what is that? I think, sorry, pin number 3. It's on pin number 3 of both of these transistors. And on pin number 1, we have a tiny version of that riding along some voltage because these aren't actually in the board yet, and that's fine. Pin number 2, there should be 0 volts because pin number 2 is tied to ground, and that's because these are PNP transistors. They are pulling this drive wave down to ground when it turns off so that the power supply MOSFETs turn off nice and quickly, so they don't stay on any longer than they should be, which is a problem if they do. So turn the power supply off, like so, and the next thing that we need to do is replace these drive transistors. The original drive transistors were labelled up as this model here, which will come into focus in just a moment. Oh, it's mirrored. Okay, apologies, I will change the mirroring. Is A1274. You can just about read that if you're good at reading in mirror image. See that? A1274. So rather than using original parts, which kind of suck, I'm going to go ahead and drop in some better parts for this bad boy. We're going to have a look in here, and we're going to go for some 2SB772 PNP pull-down transistors. These are a much better option to use. They are faster and with much more current handling. Okay, just going to cut these legs a little bit shorter. Let's try and whack these in then. Number 1. and number 2. If we flip the board over, we should see the legs come through nicely. There we go. So let's solder these bad boys in. With PNP transistors, can you always use something faster? I mean, yeah, there's always something faster. So what you need to bear in mind is that with speed comes a loss in power handling generally. So transistors and semiconductor parts that are high speed will generally be lower power handling because there's less stuff inside them. And the reason that they're fast is because there's less stuff inside them. So there's less capacitance or left over from when they were on. But the higher power handling transistors and MOSFETs will generally be much harder to run and therefore much slower. You know, guys, I'm not... Hi guys, sorry for that. The OBS did a crash, which makes me wonder whether my overclock is actually stable or not. Yeah, anyway, I was saying I'm not actually too convinced whether this soldering iron cam is actually any good. I think it's just a little bit gimmicky. I think this view with the camera down is actually a little bit more reliable. And what I didn't take into account for is the fact that because the soldering iron is very, very hot, the adhesive in this tape is now just kind of coming loose. So the camera is actually just kind of wacko wobbling around all over the place. So yeah, I think in order for me to do a soldering iron cam, I might need to rethink it a little bit. I might need to buy a tiny micro USB camera that I can sort of glue onto the camera here so it's not big and bulgy, and that would work a lot better, I think. So Crazy Logics, I have actually bought a new computer, and the new computer is very fast, well, in my standards anyway. It's a heavily overclocked 4790K with a RX 580 and a Hero Maximus 7 board, 6, I don't know. It's a flipping great computer and it's on a great Crucial SSD. It's a really, really fast computer, but that is dedicated to video editing. So all the other videos that I do for you guys, that one's dedicated to that. So I'm not having that one for streaming purposes. And also I have all my OBS settings and cameras all hooked up to this computer already. It'll take me like a whole day to get the other computer set up for live streaming how I have this one. But if this one proves to be a nightmare, then I might just have to give in and carry the new computer downstairs to do live streams with. But Pedro, yeah, I'm aware that my audio is clipping. I'm not sure if you were here earlier. I said that on this live stream only, I'm using these crappy microphones built into the cameras because my good microphones are currently upstairs and they are on voiceover duties for a new video that I'm working on for you guys. So I can't currently use my RTA microphones, which is why I'm using these built-in microphones in the cameras. So I'm apologise if my audio is a little bit bad this evening. But the good microphones will be back next time, I promise, once I've finished the video that I'm working on for you guys. Okay, so we have the new buffered transistors fitted to the board. Now all that's left to do is to power the amplifier back up and make sure that these are passing the waves over to the gates correctly. So plug the power supply wires back in over here and the remote. Okay, let's get the scope up again and let's see whether we have. Now these gate resistors are quite obviously damaged, so I'm not sure there's much point in reading the values after the gate resistor because they could be a little bit skew with. So all I'm going to do is I'm going to read the value before the gate resistor, just after the drive transistor. There we go. You can see there on the scope screen, up in the corner over here, we have a 5.18 volt RMS square wave here on this bank. Let's go over and check the other bank over here. 5.18, that's correct. The other side of the board over here, 5.18, and then last but not least over this side. Yeah, cool. So that's the drive circuit for the power supply all fixed up. Now what we need to do is to replace those dead gate resistors on the power supply, and then we can fit power supply MOSFETs and see what's going on with the output section. I think I bought some brand new 22 ohm gate resistors. Turn the light back on now. So I have this great big thing full of parts, and I think my 22, I haven't labelled them up yet. This actually came from an old technician who was obviously also into electronics, and he labelled these up with whatever he was using. I haven't got round to relabelling them up yet, because it's pretty, here we go. I'm pretty sure these are 22 ohms. There we go, 22 ohms. So I have some gate resistors for this bad boy. Awesome sauce. So the way that I generally remove these old resistors is just to go it all the way from the top here. Go at it from the top. I cook up one of these pads over here. Yeah, man, this camera on top here is a bit of a pain in the butt. I'm not gonna lie. Soldering iron camera. Good idea, Bevids. Yeah, great idea. Put a freaking bulgy camera on your soldering iron. Nice work. And it's all out of focus as well, isn't it? Look at that junky freaking out of focus nonsense. If I pull it a bit closer, does it get into focus, or do I need to be further away? I think I need to be further away. Right, let's try that. That's better. Okay, so the camera's fallen down a little bit. That's better. Okay. See, I just cook it up from the top of the board here and just pull the old resistors out like this. So that's the quickest way that I found. Once the resistors are out, I'm going to clean the top of this board, and you can actually see that the board comes back pretty well. It's not actually this burnt. It's just a bunch of soot sitting on top of the board. Oh, and hey, would you look at that? I don't even think I needed to replace these resistors. But I'm doing it anyway. So guys, check this out. It's a good job, it's a good idea to do it anyway. But right, so these resistors, they looked burnt on the top, but actually on the underside, come on, get in, where the hell is the camera? On the underside, they actually are looking pretty nice and shiny, brand new. And that is just the soot from the top of the board there, making them look like they're blown, but they're actually looking pretty darn tasty from the underside. But it's a good idea to replace them anyway, so I'm glad that we are. Yes, I'm going to clean the board in a few minutes, and you guys can see the difference that makes. It's much easier to clean the board once the gate resistors are out, because the gate resistors kind of catch on the they kind of catch on the towel and on the toothbrush and stuff, and it's just a bit of a pain in the butt. Trying to bring a bit more light over here for you guys. Yeah, guys, I'm aware that the audio is bad. I'm aware that the audio is bad. Unfortunately, I can't do anything about that just now. I will fix the audio problems in the next stream when I get my RTA microphones back. So apologies for that. One, 2, 3, 4, 5, and 6. Okay, now we just got to suck the holes from those. And we've gone blurry again. This camera keeps falling down the soldering iron. I'm going to have to think up a better solution for this this camera here, because I do quite like this camera. I do quite like this camera in terms of how it looks, but it's a little bit tricky to work with, so I might have to purchase a micro USB camera so that I can attach it to the soldering iron without it getting in my way so much and without it falling down all the time, because I do quite like it being here. It's pretty cool. It looks quite cool. Oh look, the camera's moved down again. It's gone blurry again, see? I'm just going to have to drag it back up the soldering iron to get it back in focus again. Oh, now it's all over the place. There we go, so you've got 1, 2, 3, 4, 5, and there's one more over here which I missed. Where's my tweezers? Alright, cool. Oh, that's enough of that soldering on for now. Alright, so who wants to see the board get cleaned up then and see that this is actually all fine? It's actually all just fine. Nothing wrong with this board whatsoever. Alright, so we're going to take some isopropyl alcohol. Some isopropyl alcohol. If I can find where I put it. There we go. towel, spray her up. Okay, so it's not perfect, but it's not as bad as it looks, right? It's not actually like proper cooked up. Gonna give you a nice close-up of these MOSFET pads in a minute. Right, so yeah, this was all like black and burnt. So yes, okay, we have a couple of less than like slightly marked traces, but these traces, they're not like burnt, they're just like, you know, it's just a bit too much soot for the isopropyl to remove, but you know, it's fine. It's a fine, as they say. Yeah, so new gate resistor time. I'm gonna go ahead and whack some gate resistors in now. Pull that up there. Maybe this camera's better. Yeah, I think this camera's okay for what I'm doing here. I'm going to take some 22 ohm gate resistors, and these are slightly bigger than the ones that were originally in the board. Just going to slide these through the holes. Now these resistors, they're actually, I think these ones are metal film resistors. I think that's the right term. And these are, oh, that was that mosquito that freaking bit me earlier. I got bit on the hand by a mosquito earlier. You can maybe just about make it out here. Not nice. Not nice. So anyway, yeah, sorry, I was saying these are metal film resistors, I believe. And these are just a little better quality than the carbon resistors that you tend to find. They're a bit more expensive, but they are prone to fail less often on their own than carbon resistors, and they're more accurate in their resistance than carbon ones. Not that gate resistors are particularly sensitive to exact resistances like timing resistances are, but in terms of the cleanliness of the board, okay, unless this amplifier is going on display with a perspex back, it's not really that important. Like, if the board looks a bit black in certain places just because of cosmetic reasons, or because it's, you know, a slightly burnt top lacquer to the trace, it's not going to affect the functionality of the amplifier at all. The only time when burned areas affect the functionality of an amplifier is when the actual PCB material itself has carbonized and is now conducting between traces or between pads. That's pretty bad news, and that will affect the functionality of the amplifier, and you do need to, in those cases, cut away the conductive sections of PCB and either replace them or just run jumper wires over the part that you've cut away. Yeah, that's a headache when that happens, but when you haven't got the actual PCB that's conductive or that's carbonized, that's burned, it's just like a surface lacquer, then you haven't got anything to worry about. You're fine. 1, 2, 3, 4, 5, 6 over that side. Mic is clipping pretty bad. Okay, right. I'm going to turn the mic down even more, okay? So, guys, you need to tell me, am I quite loud or is it pretty quiet but it's still clipping? I'm going to turn the mic down even more, okay? I'm doing this with mouse keys on the numpad because I don't have a mouse. Okay, mic check, mic check, mic check, 1, 2. I shouldn't be anywhere near clipping. Mic check, 1, 2. I should be far from clipping. It's quiet in clipping. Oh, Jesus. Right, I'm going to try a different microphone. Okay? If this microphone is clipping, I'm going to try a different microphone. Just bear with me because I'm going to have to do this with mouse keys. Right, how do I do this? Settings. You got 0 clipping. No clipping, too quiet. Okay, I'm going to turn the volume up because the volume is actually way under clipping on OBS. Mic check 1, 2. Loud talking. Very loud talking. That shouldn't be clipping now for you guys. Your voice is normal, so only some people are saying that it's clipping. I don't know, guys. I don't know. This is the best I can do on this stream. Next stream, like I say, will have much better audio, I promise, because I'll be using the RTA microphones, okay? Right, here we go. So the resistors that I'm putting in, they're actually slightly bigger than the original ones. With resistors in circuits, you can actually use a resistor that is a higher power handling indefinitely than what was originally in the board. Obviously, just depending on fitment. If you can make it fit, there's nothing wrong with using a higher power resistor, unless the resistor is being used like a fuse to blow the resistor like a fuse if excessive current is drawn. But for most resistive tasks in a circuit, you can get away with using a larger power resistor than was originally used. It makes no difference to the circuit at all. Obviously, you can't use a lower power resistor than was originally used unless you really know that the circuit isn't going to draw excessive current from the low power resistor that you're putting in. Gate resistors, they don't pass any current really. They don't so I'm using large resistors here and kind of pointless in terms of, you know, circuit reliability. It's not going to make any difference. It's just the ones I happen to have here, and they also fit. They also fit in the holes fine. So ain't no problem with using these bad boys. Strictly Amps, how's it going? Good evening to you, sir. It's good to be back. I've actually missed doing these live streams. I just haven't been able to, due to the workshop being in a different layout and the computer being upstairs. But yeah, no, it's very nice to be back, and I plan to do far more live streams for you guys than I have been in recent times. Kevin says it's OBS that's causing the clipping. Maybe, but I've been streaming for a couple of years now with the other microphones, and I haven't had any issues with clipping. And if I have, it's because I've had the gain turned up too high. So I think it's just these awful microphones in these Logitech cameras that are causing the issue. You can see it. So I don't know if you can see, but the microphones in these cameras, I've covered it with duct tape on this one, but they're just this little thing on the end of the camera here. They're pretty crappy. So that's probably why the audio is not great. Thank you, JBL Tester, for the sub and like. Much appreciated, my friend. Much appreciated. So this is one step away from being able to fit the new power supply MOSFETs and seeing what the hell is going on with the output section. We've removed the output MOSFETs, and so that allows us to power the amplifier up even though we potentially have drive circuit faults still in the board. But I'm going to deliberately power the amplifier up with the drive circuit faults still there, just to show you what it looks like when you've got a drive circuit problem, because I think that's pretty useful sometimes. Yeah, but I'm looking for a schematic for the HCCA 8000. Any chance you're in the know? I'm trying to think if I've ever needed a schematic for one of those things. I could probably get you one. I have a few contacts. What parts is it that you need the schematic for? Because most of those parts are labelled in those amplifiers. Or if it's resistors and stuff that's burned, most of it's mirrored. It's a full bridge amplifier, so you've got two completely separate amplifiers in the same case. So if one of the amplifiers has survived, then you can use that as a mirror image to work out what the part is that you're missing or that's blown on the other one. Okay, there we go. All soldered in. Let's cut those legs off. Now I actually keep, so all these resistor legs that I'm cutting off right now, I put these into a separate tray and I keep these, and they're extremely useful for when I have an amplifier that comes in with broken traces and I need to like jump over the traces or make a reconnection, or if I need to jump pins on IC chip temporarily. These little old resistor legs are very useful for that. So obviously you don't need to keep every single one of them, but I'd keep a few of them at hand. Just put them to one side, put them in a little bag or a little tray, just so you've got some equal length, nice, fresh bits of component lead that you can use for all sorts of things. They were looking for component values on the PWM drive circuit and on the main board. I'm trying to remember what those used. I've got a feeling that those amplifiers use the IR, it's the 2010S. I think it's the IR 2010S, or it could be a 2113S. But either of those chips will work, believe it or not. So try, it's a full bridge. I would whack in the 2010S. IR 2010S. Those are the chips that I would use. Okay, cool. That's ready to go. I've just noticed a couple of these MOSFET holes still have a bit of solder in them, so I'm just going to suck that out. And then we can fit some power supply MOSFETs.
Here's what I found on the web.
Google is deciding to talk to me for no reason. There we go. Dennis says PWM board for the power supply. You wouldn't need to change the PWM chip for the power supply. It would either be one of two things. It would either be TL494 or it'll be SG3525. I can't remember because the one of those that I've repaired. Generally, when the power supply dies, those PWM generation chips are fine. There's nothing wrong with them, so you never need to replace them. So I can't remember what one it uses, but it's either a 494 or a 3525. But you probably don't need to replace it. Okay, I think it's new MOSFET time. So these amplifiers for power supply MOSFETs use the 064N MOSFET, which is one of these parts. So let's go ahead and whack some of these in. Did I suck enough solder from these holes? Yes, I did. These ones are a little bit of a tight squeeze to get in. Some amplifiers you'll find the holes for these legs are a good size, and when you suck all the solder from them, they go in pretty easy. But sometimes, like on this one, the holes are only just a slight bit bigger than the legs that you're pushing through. And even when you suck the solder from the holes, like a tiny layer of solder will still remain on the via, so it makes them even smaller still. So you do have to kind of wiggle them in a little bit. So scrape and base, if you check on the screen here, you can see that this current amplifier is a solid F2500D. JBL Tester says, I have a broken amp, it does turn on, I tried radio augs and it doesn't come sound in speakers, it's vintage. The channels are turned on but no sound is coming out. I assume that that is like a home integrated mains amplifier. I wouldn't really be able to tell you where to look because I don't repair those things. So I wouldn't really be able to tell you, oh yeah, check this resistor and this capacitor and this, because I don't do those. If it was a car amplifier that turns on and is not getting any sound, if it's a Class D, then it means that either there's no Class D PWM switching going on in the output section, or it means that the audio signal is not finding its way through to the output section. Probably due to VCC voltage regulators not working properly. Come on, get in the hole. That's better, that's what I'm talking about, yo. So Chad says that he needs a Sundown NS1 schematic to find burn components on the speaker inputs. I'm a bit confused what you mean by speaker inputs. Do you mean the speaker output terminals, the subwoofer output terminals, or do you mean the RCA inputs terminals? Or because NS1s don't have a speaker input that I know of. And Chad, if you're not sure, then feel free to send a picture of the burn components to me on Facebook. If you go to Facebook and type in BearVids, then you'll find that I have a Facebook page. So just go ahead and just send a picture. Be like, yo, got these burn components up in here. What are they? And I'll see if I can tell you what they are. Yeah, so Josh is right in saying that the Sundown, the smaller Sundown amplifiers will have the same basic circuit architecture, so you could use those schematics if you can find them easier to most likely find the parts that you're looking for. JBL Tester, yep, no problemo, buddy. Good to have you on the stream. Thanks for dropping in. Dennis says I've removed all output MOSFETs on the amp side, plus his driver board. Oh, plus its driver board. The amp turns on and the voltage rails seem to be within reasonable values, and so are the other low voltage supplies. The output relay energizes, then it de-energizes. That's probably because you haven't got any output MOSFETs in. So the amplifier, in some of these amplifiers, they will detect that there is no Class D switching going on, and so it will disengage the output relay. So the reason that the relay is clicking on and off is probably because you haven't got any output MOSFETs in there. So confirm that you have good drive waves on the gate pads of the output section first, then put some output MOSFETs in and see if it fires up. Check that you have good switching waves on pin number 2 of the low side MOSFET, and then the relay should stay engaged. Jerry, yeah, no problem, buddy. Bring your edge down anytime you like, my man. Okay, so that's all the power supply MOSFETs loaded up here, so I'm just going to go ahead and solder these bad boys in. And I wonder whether I can, how's this camera looking on the iron? Oh yeah, it's still looking relatively intact. So guys that have been with my streams for a while now, can you tell me honestly, what is better? What was better, the head cam that was strapped to my hat that allowed you to see what I was doing from my perspective, or this, the soldering iron cami boy? What was easier to watch and what looked a bit cooler? The head cam or the soldering iron cami boy? Obviously I need to work on revising this camera a bit, getting it a bit more in focus at all times, but this is a little V1 prototype. If you guys like this camera, then I will revise it and try and get it a bit more reliable. So what have we got in the chat? We've got a few, got a vote for the head cam from Matthew. A couple other people saying the gaff cam is the best, soldering iron cam is cool, gaff cam, solder cam, head cam is cool and involving but harder to focus. Yeah, because it's difficult to hold my head steady. Yeah, the head cam is way more like jumpy around. I think this is a little bit more stable, this one. So Dennis, in that case, it could just be that the relay circuit is a bit faulty. So I would start looking at which transistor is engaging the relay, change that. You can temporarily bypass the relay if you like and just hook it up to a subwoofer and check that the amplifier works and it plays a subwoofer for a reasonable amount of time. But there'll be a transistor that is responsible for engaging and disengaging the relay. In a lot of these modern amplifiers, the transistor is on the power supply drive board. And you've done that and it works. So yeah, I would say that it's the relay engage circuit. Martin says MOSFETs is a common problem in the amplifier. Yeah, absolutely. So the MOSFETs is the thing that's actually doing the power. The MOSFETs are the component that's actually passing the power to the subwoofers. So what happens is if there's an amplifier fault, these things get taken out first, usually. So at the moment I can't use both the head cam and the soldering cam because the webcam that was attached to my hat is now strapped to the soldering iron. So I only have so many webcams. It's a choice. It's a choice that you have to choose between the head cam and the soldering iron cam because I can't have both. Now because some of these traces are a little bit old and a little bit damaged from the heat from when this amplifier blew, we do have some of these ground traces not actually, the solder hasn't flown up to the ground trace. So as you can see here, we have the middle pin is 12 volt and this last pin is ground, and that's supposed to have a nice solder ball on it that's flowed up from the bottom. But because the via is probably damaged because of the heat from when it blew, it hasn't really flown up that well. So I'm just going to add a blob of solder to the top of the board here on the ground trace. Now these ones look pretty good this side actually. I have to say these ones look right, that one's a bit dodgy. But yeah, these ones actually look pretty nice. Just to show you what I'm talking about. See there, we've got a nice big blob of solder on the top of these, and you can see there this one was one that had the board a little bit blackened there on that ground trace, but that's fine. Okay, who's ready to whack some power through this end? So power supply MOSFETs are in and ready to rumble. First thing I'm going to do before I go any further is turn the soldering iron off and then lift up this and just bash this on the floor on the side of my chair here to remove any loose solder that was sitting on it. Give it a brush, because when we power this amplifier up we're going to have some high voltages going on the rails and we don't want any bits of solder there shorting out the bottom of the board. Cool. I wonder, can I zoom out a little bit on this camera? I don't know if it's zoomed in at all. Oh, that's better. That was zoomed in a bit much. Okay, so let's plug the power wires back in once more, and this time I'm actually going to screw them down. so that sufficient current can pass. And for long-term subscribers that have been wondering about updates for the Proton door cards, they are currently 97% complete. I will be doing a full overview video of them probably next week once they are at 99% completion, and they look freaking awesome. They are super cool now. They've been properly vinyled and finished off, yeah, they're probably the best looking, like some of the best looking door cards I've ever seen, and definitely some of the best sounding in terms of sound quality. Like mid-bass response from them is just horrific. If you're new here and you don't know what my door cards are, they're a single 6.5, but it's in a transmission line box on the door, like all fabricated to look like a regular door card. So it's a proper transmission line enclosure, but it's a door card. It's quite phenomenal. Strictly Amp says he would choose the hat cam. Cool. I think at the moment we have more votes for the solder cam, and because it's a new cool thing and it's a little bit like, oh my god, this guy's got a camera strapped to his soldering iron. I think I'm going to improve and work on the soldering iron camera, I might be able to make it a permanent fixture. At the moment, because all my cameras are USB webcams, I have completely used up all the USB ports on my computer, and even if I added some more via the USB headers on the motherboard itself, the actual chip, I think it's the Southbridge chip, that, or whatever part of the motherboard is dealing with the USB data, is actually maxing out. If I add any more cameras, the thing just can't handle it. So one thing they're doing is getting a PCIe or whatever USB board. So it's just a PCI slot board that just has a bunch of USBs on it, and that will take some of the load off of whatever chip is dealing with the regular USB control, and yeah, that should improve the performance a little bit. Okay, cool. Now let's power this up. Take my scope probe here, and what we're looking for is rail voltages in the correct locations. I'm going to take you to this camera now, if I can hopefully get a good view of the output section board here. Yep, and I'm going to show you this set over here, I think. Okay, so this amplifier, like I said earlier, is an older style Class D amplifier, and whereas most modern Class D half-bridge amplifiers have a high side and a low side that has rail voltages in different places, these amplifiers don't. What we're looking for is on the low side, we are looking for negative rail voltage on pins 1 and 3 of the low side FETs, and the high side FETs we are looking for positive rail voltage on pins 1 and 3. So let's see if we have that. I think the low side is the 640Ns and the high side is the 9640s from memory. And I also need to check and confirm that the power supply repair I've just done actually works as well. That should probably be the first thing that I do. So I'm just going to go ahead and probe the power supply MOSFET over here. Let's do this one over here so you can see what I'm doing. So I'm probing the back of the power supply MOSFET. I'm going to current limit to about, oh, why is that? This camera view is backwards. The other ones aren't. I'm going to just allow 4 amps to pass. You can see here that this is the first stream back in action, and there's a few teething issues with camera angles and mirror imaging and audio, but we'll get there. So I'm going to take you to the scope screen and let you see the power supply start up. Oops, that's the wrong pedal. I always press the wrong pedal there. That's the pedal for the... Right, there we go. So a little square wave there started to emerge, and that will have applied a little bit of rail voltage into the amplifier. So I can go ahead and see where that rail voltage is residing. We have plus 8 volts worth of rail voltage on the high side here, gate and drain, and sorry, source, and the low side we have negative 4 volts. Yeah, it's about the same. I'm going to just pulse it a little bit more to let a little bit more rail voltage in. Ah, wrong pedal again. There we go. See the rail voltage now, I've got 22 volts of high rail, and negative, there we go, that's about correct. So we don't have any voltages where they shouldn't be, which is pretty nice. So what I'm going to do is turn the amplifier on fully now and probe the power supply MOSFETs and just make sure that the square wave here looks good on power supply. There we go. That looks nice. And as you can see here on the screen, we're only drawing 1 amp. So just make sure that these power supply waves look identical across the whole amp. That's looking good. Turn her off. Make sure none of the power supply FETs are getting hot. They should all be stone cold. Nice. So the power supply section repair is done and dusted. Let's move on to the output section then. So on the output section, with no output MOSFETs fitted, I can't remember on these amplifiers whether we see a drive wave or not. Sometimes with the FETs out, you see a drive wave on the low and high side. Sometimes you need to feed it with some RCA signal. So I'm just going to go ahead and power up again and see whether we can see if there is any little drive waves attempting to build on the low side gate. Let's start with. There we go. So something happened, but it didn't look pretty. What I'm going to do, just so you can see it, I'm going to zoom right out on my scope. I'm going to zoom right out on my scope to 50 milliseconds. No, I'm going to go even slower. I'm going to go maybe 200 milliseconds. And you can see exactly what the low side drive just did. Oh, it's not going to do it again now, is it? Oh, there we go. There we go. I'm going to zoom in just a touch. So you see that little bump there? That's turning on fully, which I don't think it's supposed to do. Let's test that on the high side. The high side doesn't do anything whatsoever. So this is the side of the amplifier which failed. Okay. The other side, which didn't appear to have any failures going on, let's see what that one's doing. Okay, so that's actually doing the same thing on the low side. And how about the high side? That's doing the same thing. Okie dokie. So I've got a feeling that this is one of those amplifiers that needs an RCA signal in order to send some switching pulses to the output FETs while the output MOSFETs are out of the board. So I'm going to go ahead and take an RCA lead right here. Oh! I don't know how well the microphone will pick that up there, but someone would just bowl down the street with a banging beeline. Sounded pretty good. There is another guy around here that has a system, because I don't know who he is, but I hear it from time to time. Got to go and check it out and say, yo, what's up? Just setting the gain to 0 on this. Set to master. Okay, so we've got our RCA input in. I'm going to go ahead and turn on my signal generator, which I might be able to show you with this camera. Not really. You can't see it. Little signal generator, little cheapy thing. So I'm going to go ahead and feed this with a 40 Hz sine wave. And see, if we feed this with a 40 Hz sine wave, we should then get a 40 Hz square wave on the gates of the output section. Let's see what we got. Go ahead and do that up here. That's a bit easier. So let's go to the good side of the amplifier first. 5 milliseconds. So the good side of the amplifier should show this as a square wave, if I remember correctly from these. There we go. That's what I wanted to see from the OS. So there we go. Good side of the amplifier with a 40 Hz sine wave in shows us a 40 Hz square wave riding along the negative route, and the same thing happens. Oh no, it doesn't happen on the high side. I was going to say the same thing should happen on the high side, but I don't think it does. I think the high side needs the low side to oscillate. Maybe. Or maybe the high side's fucked. I thought the high side should oscillate on these amplifiers. Let's check the other side of the amplifier then. The side of the amplifier that was blown. interesting. We do have a square wave on the low side here, and we also do on the high side, but only on one. Interesting. Okay, so the way these amplifiers work is we should have a square wave that appears on the low side and high side with no FET-SIM with signal fed. But we only have that on some of these. So we only have that on this bank and this bank, high and low. This low bank we do, but this high bank we don't. And let's go over here. This high bank we don't. And on this side, neither of the high banks are working. So, what we're going to do is we're going to have a look at the driver board. I'm going to spin this around so you can see what I'm doing. Where is the angle that I want? Okay, so we can see here that there has clearly been some kind of over here, and that could be to do with the high output, but that would be for this side. So this one over here is responsible for this opposite side of the board, which didn't have any square waves going to the high side. So each one of these transistors, I'm going to actually I want to turn my scope screen off. Maybe I'll have to zoom out a little bit here. I want you guys to see this up and clear, and I might actually turn the light off. Does that make it any easier? No, I think that makes it. Yeah, that makes it a little easier, I think, doesn't it? Maybe it's a little bit overexposed. These small transistors here, which are SOT23 components, these are responsible for passing those drive waves to these NPN and PNP transistors, which are the ones which are driving the MOSFETs. So if we probe these bad boys, we should see some drive waves. There we go, got a drive wave on this one, and that's the high. So we don't have an output to that. So you see this one here has an input, and it has the high rail on pin number 2, but it doesn't have an output. Let's go along to this next one. This next one has an input. On pin number 2, it has the high rail with the wave on it. And it also has the wave on pin number 3. So that's what it needs to be looking like, I reckon. This next one along has input. Output has the low rail with a wave on it. And then it has a wave that looks like that. And then this last one over here has the input wave. On pin number 3 it has the wave that looks like that, which means that we should also have the drive wave on that. So we have an issue then with this 1D over here, and that could either be an issue with this transistor, or it could be an issue with the drivers themselves being shorted and pulling that down. So as you can see here, we don't have anything on this drive over here. Interestingly though, on this 1D we did have the correct waves on the 1D, but it didn't appear on the board. It does appear on the drivers though, but it doesn't seem to appear on the board, which is interesting. It does appear on the board. Okay, so this side it is actually there, but just not on some of the pins. That means we've got dead gate resistors. So okay, this side of the board seems to be working okay. And did we have dead gate resistors on this side as well, making my results look a bit skewed? No, they didn't. Okay, so that then marries in perfectly with what we're seeing on the driver board. We have one high side not working on the 1D over here. This high side is working, this low side is working, and this low side is working. So we have one little bank over here that's not running properly. Let's take our attention to the other side of the board over here, the side that had all the dead MOSFETs on it. So here we have low sides, both apparently working fine. High sides, we have one high side working fine, and oh, do we have both high sides working fine now? I'm sure one of these wasn't working before. Hey, playing games with my ass. Both high sides appear to be working fine. So this here that has black gunk on it, is that working then? It is. Look at that. What the fuck? That's random. I would have given you any money that was dead. Let's clean that up with some isopropyl alcohol. I'm intrigued now. Is that just soot maybe from something? But that's a bit of a way off. That's a bit of a way off. Maybe I don't know. I'm going to replace it anyway, but I'm just interested. I'm just going to wait for the rail voltage in the amplifier to sink down to ground before I spray alcohol on that jazz. So we still have 33, 32 volts in there. Let's have a quick look at the live chat while we're waiting for the voltage to sink down there. So Brandon says, is the car all fixed up? Still a mechanical motor issue. Yeah, the Proton is working perfectly. It did need a new engine, so it's on engine number 2 now after 8 years of ownership. And sadly, the reason the engine died was not because the engine died, freaking stupid issue. So the cam belt has a plastic cover that goes over the cam belt, and one of the clips that clips the plastic cover over the cam belt came off. Plastic got a bit brittle maybe at high RPM, so I was flooring it, okay, and a bit of this plastic clip came off from the cover, and it got picked up by the belt teeth, and the bit of plastic went in between the belt and the crank, the cog. So obviously the flipping things, the cog skipped a few teeth or whatever and completely ruined all of my valves, and so yeah, the engine was toast. So sadly the engine was, there was nothing wrong with the engine, it was going along happily. Stupid bit of plastic knocked the timing out of alignment and killed the engine. Super annoying. So what are we at on the rail voltage now? Are we safe enough to... oh yeah, 3 volts on the rails. Alright, so let's spray that up and see why is that bit all blackened like that? Trusty old toothbrush. So that's actually come up really nicely. I don't know where that soot came from. Does it come from this cap maybe? Ah, hang on a minute. Oh no, maybe not. I was thinking it would come from this cap, but it's not come from the cap. I am bamboozled. I don't know where that soot came from, guys. Unless there is one other possible reason that this failed like that. It is very possible that a tiny teeny strand of copper wire, like speaker wire, came in here and fell on the board here, and it just got obliterated by the high voltage, just vaporized, and that's what's left all the marks. But as far as these transistors are concerned, there's nothing wrong with it. Like, I mean, they're working, they're passing the drive. Weird, super weird one that. Right, so what I will be doing is I will be changing this 1D transistor over here. That is in line with these. And I'm also going to be checking the resistance on this 470 ohm resistor. Maybe this camera will focus that close, I don't know. Just next to this 1D transistor there is a 470 ohm resistor. Now these things run pretty hot and they have a tendency to go open. So I'm just going to go ahead and take my multimeter and check the resistance on that. And that's this one right here. Yeah, so we still have 470 ohms, 471. Yeah, that one's looking fine. So it's probably either this 1D transistor that's causing a fault, or it's the AG and DK transistors over on this side. So without further ado, let's get to removing that 1D transistor. Bye bye, bad guy. So I'm actually just going to put this to one side, just because I'm interested. Might be okay. I'm going to take a replacement 1D transistor, and I'm just going to freshen up the solder pads here. And I've actually recently been doing that with the hot air gun. I'll just take the piece of solder here. Look, check this out. Usually this works really well. I'm going to take the piece of solder, put it on the pad. There we go. You have to cook up the pad first a bit. How cool is that? Oh, that works a treat. Okay, so they're a little bit big, but it does work really well. So we're going to take some 1D transistor. That's a 2D. That is a 1D. There we go. That is a beautiful job. Beautiful, I tell you. So let's see if that's made any difference then. Let's see if by replacing the 1D transistor there, we now have the square waves on the side of the amplifier where we didn't before. Supply some power. There we go. I think it was this side that was bad. Was it this side? Ta-da! There you have it. Square wave on high side number 1. Square wave high side number 2. Let's go over the other side. Square wave on high side number 3. Square wave high side number 4. Low side number 1. Low side number 2. Low side number 3, low side number 4. And I'm just going to make sure that the waves don't disappear as we add more rail voltage. So I'm going to go ahead and turn the voltage up on the amplifier. Now you can see that we're only running at 10.4 volts at the moment. I'm going to go ahead and increase that up to 14 volts. And this should all stay where it is. Yeah, that's looking good. Sweet. Yeah, that's good. Cool, so now that we've confirmed that we have drive waves on every bank of the output section, we're ready to go ahead and fit some new MOSFETs. So this amplifier is an older one, like I said, that requires us to use N-channel and P-channel MOSFETs. So in this tray here we have some 9640s, which is going to be mirrored to you, you can't see it. And then in this tray over here, which I can't get off right now, I have, oh no, where is it? Here. I have a bunch of 640Ns. Hopefully I have enough in here to fit out this whole amplifier. If not, we've got to buy some more. Jack the Ripper, how's it going, my man? We all missed you, bro. It's hella late, but I made it. Yeah, it's pretty late. It's about, in the UK here, it's 10 past 11 in the evening. Hey, Ian, how's it going, man? Good to see you, bro. Hope you're well. So who knows about the next video that I've got coming up for you guys? I mentioned it earlier on the stream. If you're recent on the stream, you want to know. So I'm currently working on a video which is a teardown and a repair of a, actually I don't know, maybe I can show you. Slight mess of crap over here. So right here behind me, look at that baby. Look at that mad lad. This is the JBL A6000 GTI. Currently mid-repair, waiting for some parts to arrive on that one, and that will make a fantastic video. I'm halfway through making the video of that, and I have to say it's turning out really well. Some nice camera angles in there, really good explanation of its teardown, how the circuit works, and repair. And it's quite a complex repair as well. It's not just replace the FETs. There's a fair bit wrong with the drive circuit, some Zener diodes, and there's a few bits wrong with that amplifier, so it'd be really cool video I think it's going to be. Many thanks for the €2, Ian. Much appreciated, my friend. Yeah, so you've just joined us. The microphone that I'm using on this live stream is a piece of junk Logitech built-in microphone to the webcam, and the reason for that is because my RTA microphones that I usually use for streaming are currently upstairs, and they are being used for voiceovers for the JBL amplifier video that I'm working on. So that was a bit of a headache to unplug all that, bring it down here for the stream. So I was thinking that these microphones would be okay. Clearly they're not. They sound like junk. So in the next live stream that I do, I will be putting back the RTA microphones, because hopefully I would have finished my video on the JBL. Yeah, Jesse, good to see you. Oh, this is old school now. We've got some old school vibes going on here. Oh, it feels like a old stream from back in the day when I first started streaming. You got Jesse, Hian, Jack the Ripper, Rob C. I can't scroll up on here because I haven't got a mouse hooked up. But yeah, no, nice, good, and Josh Hansen as well. Nice. Okay, cool. What's the rail voltage sitting at now on this bad boy? Are we ready to fit some FETs into this? We have, yeah, we've got 1 volt. Yeah, we're good to go. We're good to go. So, next thing I need to do then is I need to suck the solder from all the holes from the output section FETs. That's an annoying thing I have to do. Yeah, Kian's been with me since day one. Yeah, man. Okay. Where's my socket? Here it is. My man, Charles Simpson. Thank you massively for the 10. That's much appreciated, brother. Didn't have to do that. Thanks for sharing your support, your knowledge. No worries, my man. I enjoy sharing this stuff to hopefully get more people into fixing rather than throwing away. I don't like the throwaway society that we live in. I want to get more people on board with realizing that, you know, most of the time stuff ain't really that difficult to fix. Household items are among the easiest crap to fix. Flipping toasters, kettles, washing machines mostly, unless you've got one of these freaking complicated ones with PIC and everything. I've been fixing my dad's chainsaw as well last few days. It's an electric chainsaw and it has a 2000 watt 240 volt motor, because we have 240 volt AC in the UK over here. And yeah, the brushes were completely gone on the motor. So most people, if they had their electric chainsaw die on them, like it had a lot of smoke and a lot of flames coming out the motor, most people just throw it away, buy a new one. But what we've done is we've pulled the motor apart and we've taken the brushes off, and we're going to be buying some new brushes for the motor, fixing it back up again. Bevis, have you heard of those guys behind FaceApp being Russians who harvest? Yeah, so FaceApp was actually, this is the second time it's come around. It's actually it actually went viral a couple of years ago, I think it was now, and people looked into it and it was the same issue. To be honest though, I'm not gonna lie, I have used FaceApp. I wanted to see what I looked as an old man, and it was freaking jokes. I even put a troll post on the I Just Want to Bang Facebook group of me sitting in my van, and I was like, 71 years old, still running a sick thought of war, keep banging y'all, with my old man face in my van. And loads of people bought it. Loads of people commenting like, hell yeah brother, keep rocking into your old age. It was a fantastic troll post. It's actually got 800 likes, which is quite a lot for me. If you're on I Just Want to Bang, you probably would have seen that. That's the only time that I used the FaceApp thing. Was for that picture. That's that side all done, I think. That one's a bit sketchy. Come on. Get your junk out of there, brew. I'll have to do that one from the bottom, I reckon. Yeah, so just going back to the face app thing. So what is it? I think they can have access to my gallery or whatever. I mean, I don't really give a fuck if they want to look at pictures or like use pictures of dead circuit boards, MOSFETs, the occasional selfie from myself. I don't know. Who am I kidding? I don't take selfies. What do I take? I take pictures of subs, amps, electronic components, the occasional nice picture of the garden or something, I don't know. Whatever, man. I don't give a fuck. It's not like I'm taking pictures of military secrets on my phone, bruh. Feel free, man. Use my photos if you want. Use my photos to improve facial recognition, if that's what you're doing it for. Whatever. Thunderstorm has started. Chris, my man, go get some footage of that thunderstorm. Thunderstorms are nuts. Mother Nature is a boss-ass bitch. Cool, I think we're good to go. Good to whack in some new FETs. Yeah, gotta hide them nudes, Leon. Gotta hide the nudes. Don't let the Russian get their dirty mitts on your nudes. And in my terms, nudes are just amps with the back off. Okay. MOSFETs I am now nicely on this board. Solid have decided to label up where the 640s and the 9640s go. Cheers, bro. I'm interested to get people's opinions and views actually. What do people think of 5G? There's a lot of different information online about 5G and whether it's harmful, whether whether the radiation is harmful or not. I don't have an opinion as such because I haven't read any information on it. To be honest, though, with 5G, so I've had 4G for a number of years now, and to be honest, the 4G is quicker than my broadband. I tell you what, I've not actually been in a situation before where 4G wasn't quick enough. So is 5G cool? Yeah, it's pretty cool. Do we need it? I don't know. I've never found myself in a situation where the 4G wasn't quick enough. However, I have found myself in situations in central London where, although I've got full signal of 4G, the internet speed is actually still ridiculously slow, and I believe that's probably just because there's too many people using the same channel. So yeah, if 5G can allow more users to be connected and maintain a high speed per user, then yeah, I'm all for that. Well, what are people saying about 5G is dirty, but there's no escape. We normally disappear down the sea. Oh, that's pretty cool. Yeah, I've heard that the army already use 5G in many instances. 5G is good for density rather than theoretical throughput. Okay, cool. That's what I wanted to know. So that's potentially a good thing then. So with 5G, my speeds won't be janky as fuck in London. Okay, cool. That's all the 640Ns that I need. Let's go ahead and turn our attention to 9640s. One thing I do want to check just before I whack these in, so it's kind of important that the 640Ns that I'm using and the 9640s have a relatively somewhat similar VT, which is turn on voltage. So the FET needs to turn on at roughly the same voltage. So on this one, VT, we have as 3.4 volts. You can't see that, I don't know why I'm even bothering to show you. But the VT of the 9640s that I'm using is 3.4 volts. I've got a feeling that the 640Ns are going to be somewhere up near the 4 volt mark. Oh no, 3.7, that's acceptable, that's fine. We can use these together. Yeah, if they were vastly different, like if the 9640s were a 3 volt VT and the 640Ns were like a 4.5, then that wouldn't be great. There'd be too much time in between when the 9640s would turn on too soon compared to when there'd be a gap. I think. Well, nah, yeah, you know, it wouldn't be ideal. Right, that's one side of 9640s all put in. Let's do the other side. Edward says he still needs his what was it? HCCA 2400D looking at. Are you getting any sound through it, or is it just not doing anything? The yellow flashing light doesn't necessarily mean the amp's not going to work. The ESP light tends to play around a bit, especially now that the PIC chips are starting to die and do funky things. But sometimes, even with the ESP light flashing and flickering, doing all kinds of weird jazz, the amp can still work. That's one thing I wanted to ask you guys. So just as a show of hands in the live chat, how many of you are watching this on your phone? How many people of you are watching this on like a desktop computer or something? And do the people that are watching it on a desktop computer or TV or something, are you listening to this on stereo speakers? Because it depends whether I hook up my stereo RTA mics or just a single mono one above my head. If most people are watching on a mobile phone, I'll just hook up the one mono mic above the head. That'll give you the best experience on a phone. But if most people are watching using some kind of speakers, left and right, I'll hook up the stereo ones because it sounds pretty sweet. Let me know. Kevin's watching on TV. Headphones, desktop headphones. Doesn't care, use mono. What's going on, Just Me IDK? I'm just going to solder one leg of these from the top of the board here to secure them in, so when I turn the board upside down they don't fall out. And the one that I'm choosing to solder from the top is the one that actually has the power trace running from the top, which is the drain. That makes more sense. That means that we're going to have a good connection to drain at all times. What's going on, Seth, my man? Thank you very much for the 5, buddy. Much appreciated. Good to see you back on the stream. I was saying earlier I was getting some nice old school stream vibes. I had a lot of guys from back in the day when I started streaming on the stream. It's good to see. I hope you've been well, my man. Hope the life's treating you well. What do you think of the new camera angle? Soldering iron camera. Bevis, by the way, why don't you stream so often lately? So the reason that I haven't been streaming so much lately is because I redid the workbench in the workshop, and basically I had to completely disassemble all of where the cameras were and everything, and the new setup, the way I placed everything, like the oscilloscope and everything, it didn't lend itself too well to where the cameras were before. So it's taken me a little bit of taking me a bit of time to work out how to put the cameras where I wanted them. Secondly, I had the PC, because I only had one PC for a while, and the computer was needing to be upstairs in the living area, and so I didn't have a PC down here to stream with. So now the reason that the streams are back up and running is because I've worked out where the cameras can go, and secondly I've built myself a new PC which is much better, and that is on duty upstairs for video editing. And the original PC, the original stream machine, is down here. And so yeah, this is now my first attempt at getting back up and running with the streaming, which is why we had some teething issues at the start with the audio. The audio is still not great. I hope the picture's okay. I hope that the image is alright for you guys this evening. I think that's okay. So a couple of people are watching on Chromecast using high-end stereo setup. Oh dear, if you're using a very high-end stereo setup, the audio probably sounds like whack right now. I'm old school on a PC, but really don't care about mono or stereo. So, okay, so seems like most people don't care about having stereo mics. When I listened to it back, it did sound pretty cool, because you had the soldering iron coming from that side, the pump, and you had all the, like, my voice would move as I was doing things, and I don't know, it was little details that I noticed, but to be fair, probably in the long run, just a mono mic above my head here is probably makes more sense, easier. What graphics card do you recommend for video editing? Now, this is a tough question because I myself have had some headaches with trying to find a good video editing graphics card, and maybe some of you other guys in the chat can help out here. So I did my research. I needed a graphics card that would complement workloads in Sony Vegas. And Sony Vegas can make use of GPU acceleration, and so I was then torn between the CUDA cores of the NVIDIA cards versus the Open CL, GL, Open whatever it is, of the AMD cards. However, the AMD cards, the newer ones, do also have something else, which is similar to CUDA, which helps with GPU acceleration, which Sony Vegas, the newest version, can support. Can't remember what it's called. So yeah, it was a toss-up really. I was doing research back and forth, but most of the stuff that I read seemed to say that the RX 580 would be a solid choice for good value for money and an excellent boost in performance in Sony Vegas. And yeah, I mean, I don't have much to compare it to. Well, compared to my 560 Ti, it's I think a lot better. With rendering, I can choose an AMD profile in the rendering options, which makes use of whatever thing the AMD card has, which helps out with the rendering. Yeah, it's pretty quick, but at the end of the day, video editing is always going to be predominantly CPU dependent. So the graphics card, when video editing, is less important. It can help out with timeline speeds, and it can give a boost to video rendering. But at the end of the day, the thing that's going to make the most difference in video editing is number of processors, like speed of your processor, number of cores to a point. You need good core speed and a good number of cores. Linus has been doing some videos recently with whether more cores is better or whether less cores with a higher speed, and there's like a balance point. I think it was something like 10 or 12 cores was the perfect point. Something like a Threadripper would be fantastic for video editing. I think that's one of the things they're made for. So yeah, it's a tough one. Do your research. My RX 580 is doing a great job from what I can gather. But yeah, you know, whether the difference between the 580 and using a 780 Ti or 1060 is, you know, whether it's that noticeable. It might shave off between 5 and 30 seconds from a 5-10 minute video. It's mostly down to your CPU. I don't know about Premiere. I don't use Premiere, so I'm not sure what that uses or how that can help. Thanks for the 5 again, Seth, my man. Much appreciated, buddy. Earlier, when someone drove by bumping, I thought it was someone driving behind me, but it was my subwoofers picking up the sound from your microphone. Oh, that's pretty cool. Oh, yeah. So when someone drove by, so I wasn't sure if these Logitech mics would pick up the that sound. Well, someone did drive by earlier with a pretty fat sound system, and it rattled the shelving up here. It's pretty cool. Right, cool. So, I think we are ready to fire this baby up. I've just finished soldering all the MOSFETs in, and just after soldering all the MOSFETs in, it's a good idea to check you didn't make any solder bridges. So I'm just going to take my multimeter here and go along each of the MOSFETs to make sure that there are no solder bridges between any of these banks. Yeah, that's pretty promising. Okay. So moment of truth then. This either works or it doesn't. Oh, one last thing I just want to check, which is pretty important. I want to make sure that none of the gate resistors on the output section have gone open, because that can happen when the output section fails. So in order to check gate resistors, what I can do is I can go ahead and put my multimeter probe on before the gate resistor of this FET, go along and check the resistance. Should be 10 ohms on 1, 2, 3. Do the same for this bank. 1, 2, 3. Yep, next bank. One, 2, 3. Next bank. 1, 2, 3. My hand was in the way for most of that. Apologies, I only noticed at the last minute there. Let's go ahead and do the next one's on the other side. Yep, gate resistors are all intact. Now we're ready to power it up. So what am I going to give you? I'll give you the scope screen. Okay, so what I'm going to do is I'm going to take my oscilloscope probe and I'm going to probe the drain of one of these FETs over here. It doesn't really matter which one it is, and we're going to check what the wave looks like on the screen. And on the screen we should see output switch wave, which goes from top rail to negative rail. I imagine 20 volts divide should do the job on this. And 10 nanoseconds, I think it's nanoseconds. And we're going to allow about 10 volts to pass into the amplifier. This wire is in the way of that. There we go. 10 volts to pass, and we're still going to only allow. I'm going to allow a little bit more, just about 5 amps to pass into the amplifier during power up here. Okay, moment of truth then. Let's see if it explodes or not. Oh, wrong pedal again. There we go. That came to life pretty quick. So we've got 2.7 amps worth of current draw. I'm just going to turn it off, and for that little 2 seconds of operation I'm going to go ahead and take my thermal imaging camera and just go along and make sure none of the FETs were getting excessively hot in that 2 seconds of operation, which they can do. If there's a problem somewhere, then it only takes like a couple of seconds and the FET is really hot. So just going to go along here and check we don't have any stanky hot MOSFETs. Nope, that's looking pretty good. So let's power it on again. This time hold it on for longer and keep watching with the thermal imager. Make sure the FETs don't start to heat up. Another good idea is to check the waves are the same shape between banks. So I'm going to zoom in a bit here. So this is the low side bank on this side. So I'm going to go ahead and check the high side bank. So the low side should all look the same. This low side looks like that. Pause the scope screen. Whoa, the amp just turned off then. Did it go into protect? That's interesting. I still have my foot on the pedal there. That's interesting. The rails have sunken down to ground. Okay, what happened there then? Let's take a look with our multimeter. Just make sure, see if we've got any oh dear, we lost a FET. So there's still a problem. So we lost this. Oh fucking hell! My bad. My bad. For some reason, fucking rookie error. Jesus Christ! Too much pressure on the stream. My bad. For some reason, I didn't solder this FET in. What the fuck? I think that's the first time I've done that. Wow. Stupid old boy. just goes to show you can never be too good. No matter how many times you do something, you can always make a human mistake. That's why we're human. Because we make fucking mistakes like that. Now luckily I think I only lost that one FET, hopefully. Yeah, so that I just lost that one FET because it would have sort of had a really glitchy drive. That's why the amp turned off. So pretty decent protection circuit in this, I have to say. Picked that up pretty quick. Ah, that's getting too hot to handle now. I'm being lazy here and not sucking that hole. There we go. Right, take two. That didn't happen. So, as I was saying, it's a good idea to compare all of the waves. Let's do that again. There we go, that's better. Alright. So, it's a good idea to check all the waves. So, we're going to stop the scope screen on this one, move along to the next bank over here. And so that's a new bank. That is identical. So I'm going to stop the scope screen up here. You can see it says run and stop in the corner up here. See that? I'm going to go over to the next bank over here and hit run. It's identical in every way. Go along to the other side of the board, hit run. Identical again. Other one, identical. Now let's check the high side outputs. It's freaking identical again. Yeah, it's pretty good. Pretty nice. And let's just check the drive waves on each of these. So I'm going to go ahead and turn on AC coupling and zoom in to 2 volts divide. So I want to make sure that these all look roughly the same. So this is the high side drive wave. It's got a bit of a jump up on there. It's got a bit of a boing on the end there. I don't think that's an issue. As long as they all have it, it's fine. Yep, they're all identical, which is the thing that we're looking for. The next and final test that we can do out of the heat sink is just turn the voltage up to 14.4 and pray that it doesn't explode. So I'm going to turn the voltage up from 10.1 to 14.4. Hope that nothing bad happens. Got a fair bit of current draw actually there. I'm not sure how much this amp's supposed to draw on idle, but it's getting a little higher as the voltage increases. So I'm going to turn my thermal imager back on and just see. Oh, okay. We've got, what have we got? We've got something getting. Fuck! There's a MOSFET over here that's getting to 112 degrees. Wow, something over here is not happy. So there's a MOSFET over here that is cooking up like a boss. And that is one of the 9640s. Can you see that on the camera? So there's a 9640 over here that's cooking up something ridiculous. And it could be that that one was damaged when I made the rookie error. None of the other MOSFETs are heating up. So what I'm going to do is just go ahead and check that with the multimeter to see what's going on. So the readings appear fine here. Gate resistance is fine. So why would you be heating up, my friend? Are you the same as everyone else? Ah, no, you're a completely different FET. Rookie error number 2. So these FETs, it was obviously in the wrong box, but these look identical in every way other than one small thing. They have a slightly different number. Rookie error number 2. Come on, focus. So the ones that are in the board that it should be, these are IRF 9640s. It's in mirror. But this one is an IRF 5640. Wait, no it's not. No, it's not the wrong part. Oh no, it is a... Yeah, it's a 9540. Yep, so rookie error number 2. Don't put 9540s in parallel with 9640s. Why was there a 9540 in my 9640 drawer? For goodness sake. Who put that there? It definitely wasn't me. I would never put that there. Yeah, it's just by chance that these 9540s are like the exact same factory and like they're identical in every way to the 9640s, and also the markings on them, the model markings are very faint, and so the 5 kind of looks a bit like a 6 unless you look real close. So yep, rookie error number 2. So Ken, how's it going, buddy? Sorry I'm late. What amp is this? So if you want to check on the video, there's a little thing in the corner that says current amplifier solid F2500D. That's what we're working on. Rookie error number 3, there's no beer. No, I agree with you on that one. Man, it's flipping sweltering. I could do with a drink actually. I'm just going to have some soft drink, but often I have a beer on the go. But it denies. Yeah, so I need to get myself a 9640 instead. There we go. There's one. 9640. I told you there'd be some teething issues. First stream back and making a bit of a mash of things. Although it's a good job that I go through the tests that I do. So like, you know, at the end of the day we are all human. We can make mistakes and stuff like that. So I do these tests just to, well, first to make sure that the amplifier doesn't have any further issues, but also to make sure I haven't made an error somewhere. So that's why, like I say, I start off with a low voltage going into the amplifier, check all the drive waves are perfect, then I start gradually increasing the voltage, monitoring the current draw to the amplifier, monitoring the heat of all the components on the amplifier. And it's only by doing that I found this issue. Like some other people, or like maybe myself back in the day, will have seen all those beautiful looking waves that we just saw on the amplifier with 10 volts worth of input and gone, yeah, that's a repair. Put it back in the heatsink and powered it up, done a bench test, put it in the car at 14.4 volts. That 9540 would have shat its pants and possibly killed the power supply again. So, yeah. We can all make mistakes, but as long as you do the required quality checks to make sure that your mistakes don't go unnoticed, you're all good. Alright, so hopefully, last and final power up then, before we deem this a success. I'm going to probe the high side this time. There we go, 2.7 amps again, and I'm going to take my thermal imager one more time. And confirm that nothing is getting to 100 and whatever degrees. Okay, so now let's start cranking up the voltage, and the current shouldn't jump up like it did before. .2 volts, 3.2 amps, sorry, 11.4. Just going over the board with my thermal imager, checking every MOSFET for heat. It's looking good now. On the driver board always runs a bit hot. Actually, part of this driver board circuit is running a little hotter than the rest of it. We've got 63 degrees on part of this drive circuit over here. One half of the drive circuit is reading as 63 degrees. The other side of the drive circuit is reading as... oh, it's the same. It's the same. So yeah, these drive circuits just run freaking hot. That's fine. So let's crank up a bit further to 12.5 volts, 12.6 volts now. We've got 3.4 amps of current draw. MOSFETs are staying cool. And let's go up to 14 volts now. 3.8 amps worth of current draw. MOSFETs are still staying cool. 14.7 volts. Temperature on the drive circuit is now reaching to 75, 77 degrees. Yeah, these drive circuits run bloody hot, don't they? Wow. .78 degrees on the drive circuit. That's stanky hot. Yeah, still in spec, but you know, it's pretty janky. Like, it's a pretty hot operation. And so, right, not only is that, so at 14.4 volt, 14.7 volts, that was after what, I don't know, a minute, 2 minutes of operation, and that was at 78 degrees Celsius. That was open on the workbench. That was open. With this in a case, with the MOSFETs getting hot and the case getting hot, and no airflow, this doesn't have any fans, I reckon that these drive transistors would easily reach over 100 degrees Celsius. Which, yeah, again, still in spec technically, but it's bloody hot, man. You need to keep that cool. It's not good for endurance, not good for reliability. But at the end of the day, yes, I would consider this a successful repair. The only next thing to do is to put it back in the heatsink and then wire it up for a bench test to make sure it makes rated power, make sure that it does that reliably, and run an endurance test to make sure that it can do reasonable power. I usually run endurance tests anywhere between 50 and 75% of output power for a 45-minute period, usually. If it passes that, it's good to go back to the customer. And I also need to, as if you were here earlier, I need to secure the driver board back down so it doesn't come wiggling out of its headers like it did when the sample first came in. Let's have a look at the live chat. Rox Victor says, new to repairing, I look at a lot of bear vids from Trinidad. Thanks for tuning in, man. It's good to have you on board. Yo, River Alley. Nice to see you back on the stream. Have you seen the new Sundown amps? Yeah, I saw the post EXO put up of the new Sundown full bridge amplifiers. And so yeah, probably going to be fine. But I don't, obviously, so this is something that people need to know, that general car audio users won't be aware, but like these brands don't design and make amplifiers. So Sundown amplifiers are not designed or anything by Sundown. They are pretty much off-the-shelf circuit designs from Xenon or S&I. Couple of tweaks made by Sundown. Yeah, put these caps, make more caps here, put these FETs, slightly bigger FETs, put these power terminals on here. But at the end of the day, the circuit, the amplifier is exactly the same as what everyone else is using. So the only brands that have truly made their own bespoke amplifier circuit are the brands like JBL, Alpine, Rockford Fosgate, JL Audio, etc., that have these amplifiers where the circuit architecture and everything, the actual proper design, isn't shared by anyone else. I mean, at the end of the day, there are only a select number of ways to create a Class D circuit. There's only a limited number of drive chips that can be used. There's MOSFETs are going to be, they're going to be using near on the best MOSFETs available, on these modern amplifiers. So at the end of the day, again, amps will share MOSFET models and stuff, but I like to see a amplifier where the manufacturer has employed some true amplifier design technicians and made something from scratch that is solely that brand, like JL Audio, like Rockford Fosgate, Alpine, JBL, Classic. Yeah, that's proper stuff. Sundown, they don't do that. They don't employ a amp design technician that will design them something from the ground up. And so I don't believe that that's been done with these new budget line full bridge amplifiers from Sundown. To me, they look like they're going to be something done by one of the Brazilian companies, like how Sound Digital made a partnership with Ground Zero and made a bunch of amplifiers for Ground Zero. So all these Ground Zero small full bridge amplifiers are Sound Digitals, and I think that actually, fair play, they say Sound Digital on the box somewhere in partnership with, and if you take the board, the back off the amplifier, you can see Sound Digital is all written inside the board. So I believe that Sundown have done a similar thing here, and the one thing that stands out to me that made me think, yeah, this isn't actually something new made by Sundown, this is a Brazilian company that's done this, is the amplifiers only have one RCA input. They only need one RCA input. That's all that a mono amplifier needs. But for however many years now, bass amplifiers have come with two RCA inputs. That's just how people have been doing it. And if Sundown had made their own amplifier from scratch, I would put my money on the fact that they would include two RCAs, just because people like it. People don't like change. If you look at the comments of the picture that EXO shared, loads of people are gassing off about, why is it using a wire splitter for the, no, has it got one RCA input? I've got to leave one dangling, or does it still get 4 volts? There's all sorts of people don't like it. People just generally are used to having two RCA inputs in a mono amplifier. Just leave it at that. So the fact that these only have one RCA input, that leads me to believe that this is actually a Brazilian company that have made these circuits, because all the Brazilian amplifiers only have one RCA input. Yeah, they do. Yeah, the Tarams, the Banda, Stetson, I think. Yeah, most of them just have one RC input. So, yeah, they're not made by Sundown. Whether they'll be any good or not, who knows? Depends. Have to wait and see what the circuits are like. Crazy Logic says if you look in the Class D sections of Perry's amplifier guide, he shows some fabricated heat sinks for some of those drive circuits. Yeah, I've seen those actually, and not just on these boards, but also on the upright ones using the IRS 21844S. You can heat sink these boards using a plate of copper or aluminium, and you can attach it to the board with the thermal pads. And that will improve the amplifier's reliability, especially in hot countries, used for long demos, etc. That's not something which is within the customer's budget this time around, though. My GZHA 2400 gets hot within one song too, without fans. What about Sony, says Rowan. Yeah, Sony. Yeah, Sony, not all of the amplifiers were like their own thing, but some of them were, like the Explod line of amplifiers, the hexagonal amplifiers, they were actually pretty good. Those grey hexagonal Sony Explod amplifiers that you can pick up for like $10, $20, like people were lodging them off. Those ones that say 1600 on the front, they actually bench about 950 watts at 2 ohms. Like, it's a good amount of power for what you can pick them up for. They're good amps. Serkan said, he commented on your post saying that they are the same but built in America. I thought these Sundown amps were meant to be like a budget line from Sundown. It wouldn't make any sense to have them built in America, personally. That doesn't make any sense. When assembling circuitry, you won't get a better amplifier assembling it in the US compared to going for a decent assembly in China or Korea. Obviously, if you choose a Chinese like pre-made board thing that you just, oh yeah, I want that one and that heatsink, then it'll be shit. But you know, some of the best Class D amplifiers from Digital Designs and Sundown DC Audio, they're made in Korea and China and stuff, and the circuit quality, the board, etc. is fine. It doesn't need to be made in America. You've recommended B2 in the past. Do you consider B2 amps to have a unique design? No, they don't. B2 I have a lot of respect for the brand and Jay behind B2 Audio. Wicked stuff. He's going in all the right directions with the brand. Here, B2 Audio subwoofers, they are specific to B2. He's done some pretty awesome R&D with the subwoofer lineup, and that's wicked. B2 is a bit like Digital Designs in the fact that their main thing is subwoofer production. So their subwoofers are all bespoke and they are unique to the brand. But all the other stuff that they will offer, component speakers, although B2 do have some high-end component speakers which are bespoke, but many of the general component speakers and amplifiers, they're not bespoke to B2. The MA 6000.1, however, B2's full bridge amplifier, I haven't seen that circuit design anywhere else, so it's possible that Jay worked with a factory to have that circuit design for his amplifiers. But what I'm saying is that, yeah, Jay hasn't employed a guy to sit in the office or to design a circuit from scratch that is just B2 and then have that made overseas. Jay will have gone to factories and have assembled amplifiers based on stock designs that they have and made relatively considerable tweaks to them, perhaps. But yeah, it's not a completely bespoke, unique circuit built from scratch. But I wouldn't say that doesn't mean I wouldn't recommend them. The B2 amps are built very well, and they use excellent components and great build quality. Yeah, they're pretty good. Rob C, cheers for joining in the chat, my man. Catch you later. Scarrow, what's up, man? Good to see you still keeping it real. Yeah, man. First stream back after a long break, and I intend to keep doing these streams for a while, ongoing now. Mr. Richmond, evening, my man. Good to see you on the stream. It's pretty late, actually. What is it now? 12:15. What do you think about Taramps? They're pretty cool, but they are not suited to how we want to use them in the West and in the States. So in Europe and in the States, the way that we use amplifiers, big, inefficient, low inductance subwoofers and long, low tones and bass lines, low tuning, they're not designed for that. The Taramps are designed for use in Brazil with PA speakers and kicky, punchy, non-low repetitive bass lines. If you want an amplifier from Brazil that is going to work with your big ass, inefficient 20 Hz monster woofers, go for a Banda. Banda amplifiers are the best thing to come out of Brazil so far. Henry says in a Class AB amp on the gate. What? Okay, so in a Class AB amp on the gate for the output FETs, DC and AC meet at the gate. So there's a few things there. So generally, Class AB amps don't use MOSFETs, and they don't, so therefore they don't have a gate. Generally, Class AB amplifiers use transistors. You have an NPN and a PNP transistor per channel, multiple of those. However, some Class AB amplifiers do use a MOSFET final stage, so the rather than using transistors, it does use MOSFETs in the final section of the Class AB amplifier. To be honest, the way that those work is, I don't know. I don't really repair a huge amount of Class AB amplifiers, so I don't exactly know how the bloody hell a Class AB amplifier can use MOSFETs, because it doesn't work. Like, MOSFETs need pulses, and if you remove the MOSFETs from a Class AB amplifier with a MOSFET output final stage, and you probe the gate, you get pulses. Yeah, you get like a square wave, just like you would do on a Class D amplifier. You only get the pulses when you feed signal to the amplifier. But when you put the MOSFETs back in, on the gate, there's then a sine wave. I don't know how that works. With the MOSFET out of the Class AB, you get pulses in a square wave form on the gate. When you put the MOSFET back in, you then get a sine wave on the gate. I don't know how that works. Jack says, with regards to that HIP 4080, spoke to Perry and he advised that it needs IRF 3710Z FET and absolutely nothing else. Oh, nice. Good stuff, man. Yeah, the HIP 4080 amplifiers that I've worked with haven't... No, I think they have used those FETs. I think I've just always bought the 3710Z because they looked like they would work better. They had better specs in terms of being driven, so I never tried anything else. So I didn't know whether those amplifiers would be happy with the regular non-Z variant or not. But good to know, guys. If you're ever repairing a 4080 chip amplifier from flipping 1800s, then use 3710Zs in the outputs. Yeah. Kevin says, have you ever considered to design and manufacture your own amp? Yes, absolutely. So it is my goal at some point in my future to produce NSV branded amplifiers of my own design. The design would be completely bespoke, and the way that I want to build them is to be freaking bulletproof and modular, right? So the idea in my head that I've got for my own brand of amplifiers would be a full bridge, there's no doubt about that. There's no reason to go half bridge in today's day and age. With full bridge, you can use much higher current MOSFETs, lower voltage MOSFETs, lower RDS MOSFETs, because the internal rails don't have to be as high. And there's just no reason to use half bridge anymore. Full bridge amplifiers all the way. So yeah, it'd be a full bridge design. And what it might even be like a class GH type thing, where it's sort of class AB to start with until you go for an output. It'll be a range of amplifiers, but the main thing that I want them to be is I want them to be freaking bulletproof. So some electronic components that are industrial, like server machinery, server power supplies, like electronic equipment used for industry that just can't fail. The protection circuits and the way that they're built is so clever that they're really quite hard to kill. So I want to build a mono bass amplifier that is idiot proof. No matter what you try, you can't blow it. The protection circuit is that sophisticated. You turn it up to full clip and you touch the speaker wires together, you get a spark, but the amp protects, doesn't kill anything. You wire the battery terminals up backwards, it doesn't die. You feed 12 volts into the RCAs, it doesn't die. You mount it to the sub box and it's flapping around like a bitch, it doesn't die. And if for some crazy reason you do manage to kill it and you kill the MOSFETs, I want the parts of the amplifier that you would need to replace to be modular, so that you don't have to send it for repair. You can buy an amplifier recone kit. So you take the back off the amplifier, the MOSFET and the output MOSFET parts are like hefty, like high, like flipping proper industrial grade, bolted to the rest of the board with big contact pads, so that, you know, the fact that they're bolted in doesn't matter. So you unbolt the big riser board with all the MOSFETs on it and the gate resistors and everything, whack new ones of those in, and then you take the drive circuit out completely and put a new drive circuit in. And hey presto, amp is brand new. That's what I want from these amplifiers. I want them to be almost bulletproof, and if you do manage to kill it somehow, then it's modular and you don't have to send it for repair. You can buy a recone amplifier repair kit from myself, bish bash bosh, bang it in, and it will just work. And you can even keep kits like this with you at competitions if you're wiring the amp down to stupid impedances, 0.125, 0.25 ohm, somehow manage to kill something. If my protection circuit hasn't done its job, you can just sort the parts out. Yeah, and I want the amplifier to have various sort of features. I want it to be a bit like the JL Audio amplifiers in the way that it's the same power at 1, 2 and 4 ohms. That would be something wicked to do. It combats impedance rise a little bit. I want it to do the same power at 12 volts versus 14.4 volts. I just want it to be the freaking be all and end all of car audio amplifiers. Any updates on your bass ride? Yeah, so the van, the bass van with the DDZ15s, that's done. Yeah, that's pretty much as it is. Nothing else needs to be done to that. It does 156s at like 25 hertz, and with the cabin all sealed off, it does. I think it does close to or over 160 dBs at like 63 hertz, like with it all sealed, sealed on the dash. But it's not an SPL high frequency build. It was never designed to be. I think it's just, you know, it could be louder at the high frequencies if I actually built it for that, but it was built as a musical build and to smash the 25-30 hertz range, so that's what it does with the windows open, hair tricks. That's all good. The Proton is coming along nicely. Door cards are 95% complete, and I will be doing a video on those once they are finished, and you can see exactly how the door cards go on, and the beautiful Genesis Class A amplifier that I have for the whole front stage. Nice. Jack said he spoke to Perry about that as well. He says the drivers need to be loaded to see the sine wave. Good to know. Okay, so with no load it shows the square pulses, but then when you load the gate, then you get the sine wave. Interesting. Like I said, I don't really repair many of those Class AB MOSFET final amplifiers, and the ones that I do, I don't bother really checking for the drive, Class AB. So I just repair the outputs and the drivers that appear dead, and they just generally work. Class AB repair is a bit less involved in terms of checking stuff before you fit new parts than it is on Class D. Yeah, GT50. The audio is whack as fuck this evening because I'm using some janky microphones. That'll be fixed for the next stream. Don't worry. I can guarantee there's an idiot out there that would blow your amp. Yeah, maybe that's why I want to do the modular stuff. I want it to, like how HCCA woofers, the HCCA subs were you could recone them on the fly, on field recones. They didn't use any glue, so I want it to be a bit like that with the amps. You can just repair, you just swap the parts out and it works. So this monoblock I'm fixing, this is from Kenabi. He says, I had a pair of 2SK 1946s in the power stage. Okay, hang on a minute, where's that gone? So I popped in a set of Z40s, but I'm sure that there's something better suited. 2SK 1946. I don't think I've ever seen those in the power stage before. Let me check that out. Matthew Scroter, thank you massively for the $5 Patreon subscription, my man. That is awesome stuff. Massively appreciated. Yeah, I don't know if you're still in the chat or not, but massive appreciation to that. That will go a long way, trust me. Thank you very much indeed. So we're looking at crap, where's it gone? Right, 2SK 1946. There we go. Let's have a look at what these are. And just while that's loading, what year, part of decade, can you imagine releasing your first model? Man, I don't know. Like I say, I see this as something that I want to do in the future. It's one thing repairing amplifiers and finding faults and rectifying them, but to design an amplifier from the ground up, which is what I want to do, that's a whole different ball game. That actually requires the electronics engineering degree that I don't have, and all the classes that I never took. So yeah, I can repair stuff because I am a problem solver. I can find faults and I can learn this way, but to produce something from scratch, design a circuit, that's a whole different ball game and knowledge set. So I will need to do some more electronics educationary stuff before I head down that path, I think. Okay, let's have a look at this data sheet. Yeah, Harry, man. Yeah, definitely. Now the weather's really nice. It'd be really cool to grab some food and go out for a boom. I don't really go out in the van that much, so yeah, it'd be really nice to go for a drive, listen to some tunes. Yeah, yeah, DDZ, that's what it is. Oh man, the data sheet is currently unavailable. Alright, let's try a different website. There we go. Okay, so this is a 60 volt, 50 watt, 45 amp MOSFET. I just whack IRF 3205s. Yeah, man. Just whack the IRF 3205s. That's a power supply. That'll do you fine. Would NSV stand for something? So NSV is my company, amplifier repair shop, company, place, whatever. Obviously, I don't call myself Bearvids on as a sort of company name for the amplifier stuff. NSV doesn't stand for anything. The reason I chose NSV is if you look at the logo for NSV, if you go to Facebook, type in NSV audio, you see that the logo for NSV, the N is the square wave, the S is the sine wave, and the V is a triangle wave. Those are the three most common waveforms that you'll find in amplifiers or electronics. So I thought that was freaking cool to have the three waveforms as my acronym. What it stands for, though, doesn't stand for anything. I don't know. I did once think natural sound and vision, but nothing I do has anything to do with vision. Maybe if I was, starting an AV company for home theatre products, that would work. But nah, natural sound and vision sounds cool, but it doesn't really tie in with what I do. So I guess you can make it up yourself. You can decide what NSV stands for. Yeah, Kevin, I agree that if the amps are bulletproof, it doesn't need to be modular. So I could shoot myself in the foot by making amps that are so good that they don't blow and producing amplifier modular repair kits that I then never sell because they never blow. So I do have to be careful with that one. So I guess I will decide what I'll do is that when I get to that point, I'll have some prototypes made that obviously aren't modular, and I will throw them out in the field and have them freaking abused, like seriously high temperatures, hottest day of the year, 0.25 ohms, just try and kill them basically. If the guys manage to kill them, or if I manage to kill them, then I'll be revising my design, seeing if I can prevent that from happening, prevent them being killed. If I can't prevent them being killed, then I'll go ahead with the modular design. But if I can get them so that they can't ever freaking blow, then yeah, there's no point making them modular. What power ratings would the NSV amps have? I don't know. This is like a way off into the future, but at the time that I do it, I'd like to offer a range. I'd like to offer a 1500 watt is a nice. That's a nice amp to offer a nice power range for daily booming. So yeah, I want to offer like a compact 15. It would be a freaking compact as well. It'd be compact 1500 watt. Then I'd want to probably offer a 2.8K. Then probably a 4K, and then I'd probably do a 6K because there's a few competitions that have a 6K power limit, so I'd probably do a 6K, and it'd probably be a little bit of a cheater 6K. It would be 6K at 14 volt 1 ohm, but you could wire it to 0.125 and get like 12K out of it, or like, no, what you get, like, yeah, 80, I don't know, something stupid out of it. And then by that time, I would probably quite like to do, some kind of 12 or 15K monster thing, maybe. That'd be wicked. The thing with these monster big amplifiers, especially you doing it myself, it's a bit like how Nissan produced the GTR, the R35. I'm pretty sure they made a loss initially for the first few years anyway, but it was like, this is what we can do. We want people to have this, own this, experience this, and love Nissan because it's sick. So if I produce the 12 or 15K amps, I wouldn't really be looking to put much profit margin on them, really. It would mostly be to get people with big builds and competition winning builds to represent the brand, and to be like, wow, fucking hell, that's a wicked beast of an amplifier. And it wouldn't be like a Taram's 15K, or like it wouldn't be something that's like, I mean, it would probably be reasonably small compared to one of these old 15Ks, but there would be some heft to it. It would be heat sinked like a boss. There would be like tons of very high power MOSFETs. The transformers would be similar to this bad boy that I've got over here behind me. The transformers would be proper things like this on this JBL Crown. Output inductors would be proper. It would be like an all-out thing, so it wouldn't be that small. It would be very heavy. Could stand for knackered Sam Venard, yeah. Yeah, brilliant. Could stand for that. I'm trying to get something comparable to the original. Just whack 3205s in there, man. River Valley suggests new super amplifiers, or maybe new age super amplifiers, new age subwoofer amplifiers. Maybe new age subwoofer amplifiers, or something subwoofer amplifiers. New age, never blow subwoofer amplifiers. uh, If JBL made head units and beefy subs still, I think they'd probably be best brand. They would definitely be up there. Yeah, man. So some of the old JBL subs, the GTI range, like they used the sort of similar to the XBL2 technology. They had the split. I think it was. They split coil or they split motor gap. The old JBL subs had some pretty awesome tech in them for the time, similar to the RE V3. And obviously JBL amplifiers are fantastic. Cheers again, Seth, for the 5. Thank you very much, my man. Who else makes Class H amplifiers beside Ryan? So Class H amplifiers that I've seen. Actually, this JBL Crown could be a Class H. I'm not sure. Maybe I think it's just a Class D. Yeah. But the Vibe, interesting enough, so a British brand, Vibe Audio, they make a Class GH subwoofer amplifier, which is in Class AB mode up to a certain percentage of output level, and then it goes to Class. It switches the output rails and goes more like Class D towards the top end of its power band. So that's yeah, Vibe. Got one of those. I'm trying to think who else makes them. Possibly Ground Zero had one at some point as well. Yeah, Kanabi. Kanabi, if you're using 3205s in the power supply, marry it up with 47 ohm gate resistors. Yes. Harry gives me a £5. It's for the beer money. Thanks very much, Harry, for that very, very kind donation there, my man. Yeah, we should definitely do something at some point, man. Just shoot me a Facebook message. Let me know what days you're working and that. Tomorrow I'm working on the Proton, fitting the Genesis amplifier. And Thursday I'm bowling up to Mr. Harwood Acoustics up in Colchester. Gonna do a few bits to the door cards to get them finished. So yeah, maybe Friday or maybe the weekend. Yeah, give me a shout. Let me know. So apart from the dodgy audio, the stream's actually been relatively reliable. I had one OBS crash earlier on, but it seems to be pretty stable now. And I think that was temperature related. It's cooled off a little bit now into the evening, so yeah, the stream is looking okay. I'll get the microphone sorted out for next stream so that the audio is not clippy and crappy. Got a nice RTA microphone to be above my head. But yeah, successful repair on this solid audio. It wasn't too difficult in the end. We just had to replace power supply drivers, power supply gate resistors and MOSFETs. Output section MOSFET complete refresh, and we needed to replace one of the drive pass-through transistors, a 1D on the driver board, and then it worked. Yay! What time on Thursday will you be free? I'll be at Henry's all day, man, so I'll be heading back to my house like late in the evening probably. But if it ends up being an early one, I'll let you know. Alternatively, you could probably come and chill. I need to check with Henry. Microphone sounds good now. Okay, cool. But it does clip. It does clip. It does clip when I get a bit excited. So I think the RTA microphone was a much better one to use. Yeah, cool. So I think I'm going to lock off the stream about now. Done a successful amplifier repair, had some nice chat, had a good catch up with you guys from a break in live streaming. I will be doing a lot more live streams coming up. Why I have a couple of B2 audio amplifiers, large monos to repair. I have got this JBL Crown A6000 GTI to finish doing, and that won't be live. I'm doing a proper nice video of that one, so I'll continue working on that one. Yeah, I've got some other bits and pieces. Got a Hertz HP1 mono amplifier to repair. I've got a big, what else we got? Yeah, I've got a few other bits. Got some Sundown stuff to repair. So I'll be doing some live streams of the amplifiers that I have come in that I feel will be interesting. Yeah, Rowan, the sub in the van does still have a slight issue. It's not a ripped spider, it's just an uneven spider break-in. It doesn't seem to go away. So it's playable, but at like 90% of mechanical excursion, it does some weird shit. So whether I can be bothered to get that fixed or not, I don't know. But it's I can still hair trick and I can still get it up fucking loud. So you know, it still works fine. Jack, thanks for the lovely stream, bro. Thanks very much for tuning in, and I appreciate all your guys' support. Massive appreciation, massive shout out to all you guys that join in and stay on the stream watching me do some bullshit rookie errors, fitting wrong FETs in, forgetting to solder FET legs, and all sorts of other shit like that, and still tuning in. But yeah. Nice one. Right, lock off the stream if I can actually, because I don't have a mouse. So, what key do I need to press? Oh, do I know about the cube? I have seen the cube. I don't really care too much for Kicker, but it does look pretty badass. They're using a fucking shit ton of cone area. So maybe I'll check out some videos of it, but I won't be able to experience it in person unless I go back over to the States. So, yeah, but pretty cool that they've put that much cone area in there. But yeah, anyway, cheers for joining in the stream, guys. I will try to warn you guys when I'm going live. I'll do the scheduled live thing, so if you want warning when I'm going live at a time during the day, hit the subscribe button, hit the bell icon to be notified when I'm going to be going live later on in that day, so you can, you know, if you want to check out live stream, you can maybe make some time that evening, or well, yeah, just be aware of when I'm going live. And they'll also sit tight for the amplifier repair video on this JBL Crown, because it's going to be freaking awesome. Until next time, thanks for the stream, and I'll see you in the next one. Nope, that's not the stream end button. Fuck. Where's the stream end button? There it is.